Girish. Girish, I am there. With administrator is there. No, it is mine only. Very good morning. Administrator, it
Sir,
is
good
mine
morning.
only. Please make it co-host. Okay.
Yes, sir. We have done it, sir.
Yes, please. Yes, please. Bye.
Sir, good morning, sir.
Yeah. Good morning, Dr. Girish. Am I audible?
Welcome, sir. Yes, sir. Clear and audible, sir.
Everything is fine. Okay.
Everything is fine. We'll start in some time.
I want to share the screen. You can just see. It is possible to see.
Yes, sir. It is it is about to share now. Yeah, I'm able to see.
Okay. First, I want to tell about Rub. The guys who know fully these fuzzy sets and logic, it is easy for them. For the beginners, I want to show. Okay, so that they'll get some interest. Oh, these type of things will be there. Especially the geotechnical engineering problem I have already described here. This I will explain little bit and then later I will come back to the presentation. But you could able to get the PPTs? Girish.
Hello. Yes, sir. Hello. I'm having your PPT, sir.
That through Gmail I have sent.
Yes, sir. Through Gmail.
You could able to send to all.
I'll share that with.
Have you shared those things with
participants? With Google Drive, I will send.
Okay, fine.
No, I didn't share, sir. At the end of the session, I will share, sir.
Okay, fine. No problem.
All those materials and papers what you have shared, I will definitely share.
One thing, another one I want to share. This is what is the. Can you see this? These are PPTs.
I am able to see that question paper only.
Still, question paper is there. I think that has to be closed. Yes. I think then it will going to come.
Yes, sir.
Okay, fine, no problem. Then I will close that and then I will show this later. Okay.
Okay, sir.
Now you can see this question paper is there still.
Still question paper is there. This you have to stop sharing, sir. Then you can share.
That's okay. Now anyway, it's going up and down, no?
Yes, sir. It's moving.
It's moving. It is moving.
Yes, it is moving, sir.
Yeah, it's fine. Thank you.
Thank you, sir.
Okay, you are waiting for some more participants to join? Hello, Dr. Girish.
Hello, sir. Hello, sir. There was some technical issue from my end. That's why.
No, that's okay.
Tell me, sir.
Are you waiting for the participants to join or what?
Sir, we will wait for 2 more minutes, sir. 2 more minutes.
That's okay. That's fine. No problem. I have 1 hour 15 minutes, right?
1 hour 20 minutes, sir. 1 hour 20 to 20
minutes. Fine. No problem.
5 to 10 minutes we'll have discussion.
Whatever possible, I will cover. Okay. But anyway, you can share these PPTs with them so that they will understand something.
Yes, sir. Definitely, sir. I'll share it.
Okay.
So shall we start, sir?
Yes, please. Yes, please. Go ahead.
Yes, sir. Thank you, sir. Yeah.
Thank you.
I hope my voice is audible. If the participants can confirm me with my voice, I can start the session. We can go ahead with the session. My voice is audible. Can someone just post in the chat box? Thank you. Yes, thank you. Thank you so much. Thank you so much. Good morning to all colleague faculty, institutes and professors. A very good morning, Randall, and I welcome you back once again to this AICTE sponsored online one-week short-term training program on soft computing techniques in civil engineering, particularly structural, water resources, geotechnical, remote sensing, and transportation applications. We have entered into day 2 of session 1. I would like to take this immense pleasure to introduce our today's speaker and expert, Professor Dr. G.R. Doda. Yeah. Professor G.R. Doda obtained his diploma in civil engineering in 1988, bachelor's degree in civil engineering from Basveshwaraya College of Engineering in the year 1992. Later, he obtained his master's degree in geotechnical engineering from IIT Bombay, Mumbai in the year 1995. Later, he obtained his doctoral degree also from IIT Bombay in geotechnical engineering in the year 2001. And he has started his career in IIT Madras since 2002, and he is currently working as professor in the Department of Civil Engineering at IIT Madras, Chennai. Professor Doda has 1 year experience in industry and 18 years experience in research and teaching. Professor Doda guided 14 PhD students and 7 MS students and 20 MTech dissertations so far, and currently is guiding 9+ PhD scholars and 1 MS student. Dr. Doda has published 59 papers in international journals and 42 papers in national journals, and has presented more than 120+ papers in proceedings of conferences. Adding to that, he has written 1 book and 2 monographs with his name. He is very active in continuing education programs and delivering lectures at various institutions and organizations, and motivating talks to students, academicians, and working professionals across the country. Adding to that, he is a reviewer for many international and national journals, and he has been involving in various workshops, training to the research engineers, research scholars, and faculty, and also contributed conducting several research-sponsored projects and as well as consultancy projects. With this brief introduction, I would like to hand over the session to Professor Doda. Sir. Sir, we are very happy to have you today, and we are thankful for your acceptance to this workshop and being part of this AICTE sponsored training program. Thank you, sir. Over to you.
Thank you. Thank you, Dr. Girish. Good morning to all the participants. I hope, Dr. Girish, can you see this particular slide?
No, sir. No, sir. Actually, I am seeing still this question paper.
No, that's okay. Let it be there. Let it be there. Anyway, I'm going to tell that later. First, I want to introduce what are these fuzzy sets, fuzzy logic through the question paper, so that they will get some understanding. The guys who are already working in this field, for them it is a cakewalk. The first timers, they will going to get definitely some benefit. Dear participants, we have a subject called fuzzy logic and its applications in civil engineering. Anyway, you please see very carefully. The engineering is an activity concerned with the creation of new systems for the benefit of mankind. And also, the another definition is engineering. Central activity of engineering is the development of new products or new processes or new systems. Anything you do, you have to do only these 3 things. For that matter, even other engineering specializations: new products, new processes, or new systems. Basically, here we are thinking about the new systems. Let's take some example here, what I have given. Later, anyway, I'm going to cover. But in 1.5 hours, or maybe whatever I have planned earlier for our students, in 10 hours, whatever I used to cover, I have planned to cover here. Let's see this particularly. I want to tell you what is this. First, you read this question, then I want to explain. For the function y is equal to x1 square plus x2 square minus 4x1 plus 4. These are the functional relationship. There is a dependent variable y. It may be anything. It may be your flood or runoff, or it may be a bearing capacity of your putting, or it may be a settlement of your putting. Functionally, it has been related through these variables x1, x2, like this. X1 may be your C, or x2 may be your angle of internal friction or some other parameters. If this is the case, there are some uncertainties, they are random. That means you can use a probability to quantify. First of all, you have to appreciate there are uncertainties. If you are not able to appreciate the presence of uncertainty, then comes a problem. At least please do respect, yes, there are uncertainties. You have to understand the methods of quantification. Quantification in the sense you have to assign certain number. Basically, you will going to get some mean, then you will going to get a standard deviation. If possible, you will going to get the probable distribution of that particular variable. Once you know the density function, basically probable density function, you can do everything about that particular density function. And then with respect to this fuzzy logic, I want to tell you fuzzy logic, you please understand fuzzy logic equal to computing with words. Please understand this. I want to tell you how are you going to use the words in order to make use of existing computers. Existing computers, whatever you want to do with the computers, they will take only input as numbers. Okay, whatever type of numbers, mostly zeros and one. The whatever you are seeing on the screen, background, everything will be done with zeros and one. The present computers are not that capable. You can just see whatever I am saying something, definitely you are going to get some meaning. Okay, the same thing you cannot talk with a computer. If at all you want to have interaction with a computer, your all words, these all words are called as a linguistic variables, or even group of words or linguistic variable. Even sentences are also linguistic variables. These linguistic variables won't take the numbers. That is the beauty. Now you see carefully here what will happen. X1, X2 have been given over here. In case of conventional mathematics, you have to assign only one number. X1 may be 4 or 5 or 6. If someone is going to tell X1 is around 5, let's assume X1 is around 3. The best way to describe, always you have to use a symmetry. But here in this particular problem, the X1 is a variable, it is a linguistic variable. That means X1 is a linguistic variable. I want to make use of the existing computer, but this variable has been defined as around 3. Around 3 in the sense you have to, around 3 means at least you have to assign degree of belongingness 100%. In case of classical sets or ordinary sets, if it is a member, its degree of belongingness is 100% or 1. If it is not belonging, it will not going to be there in that set. Otherwise, the degree of belongingness is 0. Whereas in case of fuzzy sets, basically what will happen, around 3, no doubt it will going to have the 100% belongingness. This is called as a membership function mu. Now you see 2, the moment you draw a line parallel to your y-axis, wherever you're going to cut, and then you move parallel to the x-axis, you're going to get this. That means 2 is also a member in this particular fuzzy set x1. These are also called as a subsets. Actually, the fuzzy set means it is a main. Around 3, that word itself is a fuzzy set. When you are going to get the subset, that's what your fuzzy set is, a subset. Now you see here 1. 1 is also member in this particular set. What is its belongingness? It is 0. This partial belongingness will be taken care in the fuzzy sets. Similarly, for x2, x2 is around 0. Around 0, at the most you can have -1 and +1. Even may around 10. Similarly, these actually in the natural language processing, we are getting a lot of understanding. I want to tell you what is the problem with the conventional logic. I hope you may be knowing. Usually people will talk sometimes. If he's talking logically, people will going to get some meaning out of it. If he's talking illogically, you will not going to get. Then you will tell this guy is not fully informed. He has not prepared well. He's just like that talking. I want to tell you, old men are very wise. You just think of old men are very wise. It may be true or false. If it is true, you can assign a number 1. If it is a false, you can assign 0. That means 0 and 1 are true or false is possible in the conventional logic. That is what is your conventional. It is also called as a predicate logic, propositional logic, or Boolean logic. Yes or no? If someone is going to pose the question, very old men, you just think of old men. That means you can get some meaning out of it in the conventional logic. The moment someone is telling very old men are wise means you cannot do anything with the conventional logic. You know at the most old men, then you can give some meaning to that statement. Basically, these are the propositions. Basically, they are the declarative statement or assertive statement. If you said very old men are wise means you don't know what to do with existing one. Old means very old. You can classify maybe more than 65 is old. Then more than 85 is very old, no doubt. Definitely the very old people may be much wiser than the old people. But then how are you going to quantify with the existing? Then this fuzzy logic will come into picture, because fuzzy logic will going to have this partial belongingness. Let's assume old men. In the classical sets, let's assume that old men is a word like a X. if you are assigning some number to that old man, some age you are assigning. If it is belonging to the classical sets, then you will assign a membership function 1, otherwise it is 0. Very old, no doubt it is also part of it, but very old you can assign 1, that means 100%. Just old you may be assigning 0.8. See, this partial belongingness is possible when you want to introduce your fuzzy logic. Basically in fuzzy logic you will always use a day-to-day language. Usually you will not use a question marks related sentence or explicit sentence at all. We will going to use always a declarative statement or assertive statement. Now another question will going to come. Very, very old men are very wise. First up, you know only wise. What about very wise? How are you going to quantify these very wise? Mathematics is very powerful. You can literally reduce all these linguistic knowledge in the computer knowledge. That's why all this is also called as artificial intelligence. Basically in artificial intelligence, what are you doing? You are doing only function approximation. Okay, at least for the time being you can understand. If you study that subject, you'll understand the broader perspective of that particular course. For the time being, artificial intelligence means just function approximation. Basically I have done here function approximation. Take for example, I have a function y. Y is f of x1 x2. This is how they are related. Even you can use a finite element, even you can use anything. This is how you have to do it. There are some methods, basically vertex method. I want to tell you, I hope you know what is cube. Okay, let's assume you have 3 variables. Okay, let's assume you have 3 variables. Somehow you have quantified something like that. 3 variable means x1, x2, x3. Somehow you have constructed, these are called as a triangular fuzzy number or else triangular fuzzy set. The moment you are assigning membership function, this is going to become triangular fuzzy number. You can have trapezoidal fuzzy number depending on the available information, or else you can have Gaussian fuzzy number with end curtailed. Gaussian number starts from minus infinity to plus infinity. Similarly, some researchers have worked on this. How are you going to approximate your function? Basically, if you want 100% accuracy, you have to go for deterministic analysis. If at all you have a complex system right now you don't know how to get a solution, but that is a very much important one. I have to get some solution. In those cases, you have to go for win-win situation. Even though I have a complex system, I don't know how to analyze with the existing so-called hard computing technique. Hard computing means basically what will happen, you have set up procedures. Take for example, you have algorithms. Here you don't have to have algorithms. I hope you may be knowing a little bit about neural network. How neural network will basically solve the problem. You have set up input and output. A part of the input and output, you will take them. Then you will going to train your network. Basically to learn like a human being. How are you teaching natural language to your own kids? You're not going to send them all of a sudden to the school. In the house, you are training them. Okay, you are training them. Later, you're going to pose a question. The human body will going to evolve. Then you're going to listen to your question and I will try to answer. That's what exactly you want to mimic through using computer. That is what is artificial intelligence. There's another vertex method I was mentioning about. You can just see your cube. Cube has 8 vertices. Okay, how are you going to make use of that cube? That is a vertex method. Let's assume you have 3 variables. Let's assume somehow you know the mean values of x1, x2, x3, and then standard deviation. I hope you know what is standard. Mean may be mu x1, mu x2, mu x3, corresponding sigma x1, sigma x2, sigma x3. Basically, in order to get the functional values, that means I want to evaluate a function. Let's assume I want to evaluate the same function. Y is equal to x1 square plus x2 square minus 4 x3 square you can take for the time being. Please, once again, you can y is equal to x1 square plus x2 square minus 4x1 minus 4x3 square plus 4. Now I have 3 variables. Anyway, one number 4 is a constant. Now you can think of for x1, x2, x3, I have a mean and standard deviation somehow, or else some expert must have given. It may be around 10, maybe variability may be around 3. That is what is your standard deviation. Second variable may be around 6 or around 7. How are you going to quantify? Literally, you are going to quantify like this. This is what is your fuzzy set. Now, what you have to do, you have to get the functional sets. Sets means, take for example, you take all 8 vertices. Basically, what you do, you take mean plus 1 standard deviation. Similarly, mean plus 1 standard deviation, mean plus another standard deviation for all the 3 variables. Now, you see basically what happened. Mean plus or minus 1 standard deviation. Now, you see here 2 raised to n. That means you have, you see, 3 variables are there. 2 raised to n is equal to 3. That means you're going to get 8. 8 numbers of sets you will going to get. That means x1, x2, x3. That means x1 plus means mean plus 1 sigma x1. Similarly, mu x2 plus 1 sigma x2. That is how you're going to get. Then you can put them, you will going to get y also you're going to have minimum 8 values. Correspondingly, you're going to get their partial belongingness. You have got y1 to y8 as a functional value. You have approximated. Then you are not going to get a single value. If you plot the output, you will also get output fuzzy set. These are the input fuzzy set. You're going to get output. Then how are you going to get meaning out of it? Finally, let's assume you want to use this. Now I want to use only one. That means I have got a fuzzy output. Fuzzy means there will be some ambiguity. You cannot specify particularly, look at this value. Now you decide, depending on the confidence, I want to consider only the left top portion of your triangle. Okay, this is also going to get, let's assume this is output fuzzy variable or your functional value. Now you can get the centroid of this. That itself is your functional value. That is how you have to make use. Now you can see one structural applications. Just I want to just introduce how one can think of use of this fuzzy logic in civil engineering. A structural design is considering for different kinds of structural beams, B1 to B4 for a new building. Laboratory experiments on the deflection resistance for these 4 kinds of beams have been performed, and the engineer wants to determine their suitability in new structure. The following data have been observed based on the overall deflection capacity of each of the beam type. No deflection, X1, X2, X3, this is the category. Some deflection is X2 and excessive deflection. If you say no deflection to computer, is cannot understand. You tell 0. Unless you give 0, computer will not going to understand. But as a human being, you will get lot of meaning out of no deflection. Okay, then some deflection, maybe certain few mm will be there. Then excessive deflection for each beam. Now you see carefully here. No deflection, that is X1. For beam B1, it is 0.4, 0.5, 0.1. Okay, similarly for B2, use the Max-Min method, determine the similarity of 4 the beams. Is there any similarity between these beams? Now here is a partial knowledge is there. There is no exact knowledge, but as a human being, you can understand. If you want your computer to understand, you have to construct the fuzzy sets for all these no deflection, some deflection and excessive deflection. You can decide depending on type of your beam. It is a RCC beam. You can think of what is the allowable deflection. When you are crossing more than the allowable, then you decide what is excessive, like that. And there are some inference rules will be there. Basically, it is a logic. If A, then B. These are the rules. Let's assume if student is putting lot of effort, definitely will be successful. If A, then B. Student putting lot of effort is if A, then he will be successful when he is a B. That these are the rules. These are there already. They must have come from millions of years of understanding. Similarly, some more things are there. You can just think of. There are ways, different ways of expressing your fuzzy sets. Usually, you can use A underscore tilde, or else you can put A superscript, some symbol. Otherwise, there will be ordinary sets. Then the two-sided Gaussian membership functions. Membership function means whatever triangle you mentioned earlier, like that you can construct. Okay. And then there is another example from our hydrology. In the field of hydrology, the study of rainfall pattern is most important. The rate of rainfall expressed here, mm per hour, falling in a particular geographic region could be described linguistically. Suppose we define membership function for the linguistic variable heavy and light as follows. Now you see carefully here. This plus is not just addition. Okay, this is a representation of fuzzy set. Heavy, anyway, it is a linguistic variable. That is a fuzzy set. Now I have assigned certain number. Heavy means 5, 8, 12, 20, 30. These are mm per hour. What is its belongingness? If they are the members of the ordinary set, all these elements 5, 8, 12, 20, and 30 will going to have 1, 1, 1, 1. If they are not a member, they are going to have 0. Usually, not going to show them in the set. Now you see 5 mm per hour. Element of fuzzy set heavy, its belongingness is 0.2 because we are going to vary from 0 to 1. Similarly, 8, its belongingness, that is a mu. Mu heavy of x, you can think of. Similarly, mu light of x. Similarly, here in the light, 30 is 0, 20.1, 12.5, 8.8, 5.1. At least one element should have 100% belongingness. Okay, then in that case, it is a proper fuzzy number. Develop the membership functions for the following linguistic phrases. Very heavy. Now you know what is heavy. Basically, very heavy means you can just think of what will happen. Okay, whether you have to square this number or you can take square root of this number. These are called as a linguistic H's in the literature, especially in natural language or artificial language. Very heavy, good, very good, bad, very bad, beautiful, very beautiful. You know what is. If you are able to give some mathematical meaning for beautiful, you can literally give meaning for very beautiful. Similarly, very heavy. You can just see basically how I'm going to do it. Fairly heavy means already you have heavy. If at all you want to construct the membership function, your elements will be same. Elements will not going to change, but you want to modify your heavy fuzzy set as a very heavy or fairly heavy means basically what you are to do, heavy raised to 2 by 3. There are some rules. Only problem with this, how are you going to get this number? That is what is some problem with the fuzzy logic. But I want to tell you right in the beginning, fuzzy logic is not the solution for all the problems. Wherever you have a complexity, so complex problem is there. Okay, you are not able to get answers using the hard computing techniques. That is the reason one has to go for it. This is related to your hydrology. Like that, you can think of very complex systems. Later, I want to tell you. This is related to geotechnical engineering. Please just see. A circular putting of size 3 meter. I hope you can visualize what is a circular putting. Subjected to uniformly distributed load of 150 kPa. The parameters E and nu, that means Young's modulus and Poisson's ratio, are fuzzy variables and are shown in figure below. This is what is the fuzzy number or fuzzy set for Young's modulus. Similarly, it is a fuzzy set for Poisson's ratio. The mean value are given over here. Estimate the immediate settlement of the putting using vertex method. Take the influence factor for the putting is 1. If you see this particular problem statement, you can get that particular formula. SI, basically they asked here immediate settlement SI is equal to QB by E. Okay, B is given here 3 meter. Q is also given 150. But what are our fuzzy variables? Load is not variable here. Our variables are Young's modulus and the Poisson's ratio. You please try to recollect that formula. QB by E in bracket 1 minus nu square into IF. IF is given as 1. Now you see basically what happened. Now only 2 variables are there. Basically you are going to get only square. Okay, your Euclidean space you are going to get only square. That means 2 raised to n. N is 2 now. 2 fuzzy variables are there. 4 will be there. Mean plus 1 standard deviation. Mean minus 1 standard deviation. Similarly, mean plus for nu and then mean minus. So that you will going to get. That means E plus nu plus E minus nu minus. Minus means from the mean you are going to deduct from here. Or else what you have to do, you can select these numbers. From 0 to 1, you can draw here at least 5. 0.2, 0.4, 0.5, 0.6, 0.8, 1. Now you can draw line parallel to your x-axis so that you are going to get this fuzzy number at 2 points. That means you have got 2 values for Young's modulus at this 0.2. Here also 2 values, similarly 0.4, 0.5, whatever. Then you use this functional in that particular formula, QB by E, 1 minus nu square into IF. So that you will going to get your output fuzzy set for immediate settlement. Let's assume somehow you got your fuzzy output like this particular triangle. Then in order to evaluate a single number, basically if you tell our immediate settlement is a fuzzy number, people will not going to understand. But you have taken care of the lot of uncertainty associated with these number. You have quantified your output. Finally, you want to tell a site engineer only one value. Now what you have to do, let's assume this is what is your output fuzzy. Basically for settlement evaluation, you have to consider the right side of the triangle, this upper portion. You take the centroid of this. There are n number. You have fuzzified. Now you have to de-fuzzify. Finally, you are going to get only one. That is what is the predicted settlement. If this predicted settlement is lesser than allowable, it is perfectly all right. Otherwise, you have to increase the diameter or else you have to increase the depth of your putting. If at all you want to get the safe bearing capacity, you have to do exactly same thing. I hope you know what is safe bearing capacity formula. First, you should know what is QU. Especially for strip putting, you have C and C, Q and Q, half, P gamma, M gamma. Now you can see C5 gamma. Let's assume they are fuzzy numbers. You can construct something like this. If you have a lot of uncertainty, you can go for triangular fuzzy number. Similarly, there are some more information. Write note on these defuzzification, approximate reasoning, membership value assignment using artificial neural networks also can be used to get this membership function. By your innate understanding, you can develop this. Okay, how you have chosen 32,000 and then 40,000, it is given in the problem. Let's assume someone has given only mean of Young's modulus, standard deviation of Young's modulus. Sometimes this may not be symmetric. It may be having skewed towards left or right. That information also you can do it. Then fuzzy non-linear simulation, especially is fuzzy used for a non-linear functional approximation. Fuzzy control, you can think of your own house appliances, especially even your what you can say washing machine. Okay, how washing machine, most of the washing machines are fuzzy controlled. Depending on the load, how much load you are going to add it, accordingly the controller speed will be adjusted. And then also dirtiness of your clothes. And then accordingly you have to, if you use only less powder, especially your washing powder, it may demand more. It may not clean your clothes properly. Like that, more than 3,500 applications are there using fuzzy logic. Now I want to tell little more thing orally. Later I'll go to the slides, please. Okay. Okay. The Girish, can you see the slides now?
No, sir. Still it is about to share. No, sir. No, sir.
1 minute. I'll just do that. I think sharing your, I'll just click here, share screen, right? Now you can see?
Yeah, now, yes, sir.
It will come. It will take time. No.
Yeah.
I can see here, but it will take some time to come there. Okay.
We are able to see now, sir.
Yes, please. Yes, please. Dear participants, whatever I have said, hopefully at least you come across some terms like a fuzzy logic is there. Basically, fuzzy logic is so powerful tool. You can compute using words. That is what is a powerful, because words day to day life we are using, group of words also we are using sentences. Now I want to tell once again what is fuzzy logic. Please understand the rough meaning. Fuzzy logic is equal to computing with words. Right now existing computers are not capable of computing with words, but basically you want to make use of your computer. That means you have to give some meaning to words or group of words, some sentences, basically declarative or assertive sentences. You are not supposed to use other kind of sentences. It is very difficult. If you are capable, yes, you can develop another fuzzy set. Your classical set is a subset of fuzzy set. Sometimes many people may not like this. Those who worked more than 50 years in classical sets, the moment you have come just now and then you are telling fuzzy logic is a super set, your classical set is a special case of fuzzy set, people may not accept. Now I told a little bit about fuzzy set already. You have seen fuzzy logic and fuzzy system. In fuzzy system, take for example your control applications. Take for example washing machine. How washing machine will going to decide? Depending on the load, depending on the dirtness, it has to increase or decrease the speed of the machine so that you can clean properly. That means already, and your air conditions. Okay, let's assume all of a sudden in your seminar hall, many people entered. Okay, how it will going to understand? You're going to understand based on some sensors. Then you're going to give instructions. Then there will be a lot of rule basis. Okay, if A then B, if temperature is this much, okay, accordingly you have to operate your controller speed. Similarly, temperature is this much. That means you're going to have different linguistic variables. Those things you are going to give some numbers through fuzzy sets. Okay, there are many steps. You please remember this. I want to tell you, linguistic variables are variables. Please understand this very carefully. I hope being young, you may be having a lot of understanding to listen in the air. Fuzzy variables are variables. Their numbers are actually, they won't take any numbers. Please understand this. Fuzzy variables are variables. Their values are not numbers. Actually, they are the words or group of words or sentences in the natural language or artificial language. Please understand this very carefully. Linguistic variables or fuzzy variables are variables. Their values are not numbers. If at all you want to use existing computer, you have to give some number. Then only computer will going to understand. Their values are not numbers, but they are words or group of words or sentences in the natural language or artificial language. How are you going to quantify? In order to quantify a fuzzy variable, you have to have certain name for that. Let's assume temperature. Temperature is a fuzzy variable. Temperature, if you say to computer, computer may not understand. You can add cold or warm or very hot and all. These are just linguistic hedges. You are modifying the meaning. Okay, very, very hot. Okay, the moment you say hot means you will understand what could be the temperature in case of degree Celsius. Okay, basically what will happen? You have the some name for that. Okay, and then you have some meaning for that. That is very, very important. The moment you say fuzzy variable, corresponding universe of discourse should be there. In natural language, you have syntax rules, then you have semantics. Syntax means like a grammatical rules, semantic means some meaning. Similarly, for the fuzzy variable, how they have defined, you can put fuzzy variable equal to, in bracket you can put, there is a meaning, name for that, and then some set of terms. Basically for temperature, you can start with cold, cool, warm, hot. Temperature can be described using these set of terms. Please understand, there is a name for that, and then set of terms like a, you will going to start with a very cold, cool, warm, and hot. That is how you have described temperature. Temperature is a fuzzy variable. You described with a set of, and then corresponding universe will be there. Okay, universe of discourse is a must. It is also set theory, and then you have to have certain syntax as well as semantic rules. This is what is the description of fuzzy variable. With this, I'll move on to this particular topic. Present topic is fuzzy sets, fuzzy logic, fuzzy systems, simulations, theory and applications. I already told, when you understand this particularly, then you can understand, you can do many things. Okay, this is a part of soft computing. I hope you know what is hard computing. Hard computing means you have set up algorithms, you have systematic procedure using high computing, your languages. High level computing languages are there: C, Fortran, Python. Using those, you are going to code, then you are going to process the data. In case of fuzzy logic or neural network, basically you will going to train using training set. Fuzzy sets, fuzzy logic, and fuzzy system. Basically, you have a fuzzy system. In the fuzzy system, invariably you're going to have the rules, rule based. These rules are, they were there since from earlier. Now people have developed many rules. Then when you have rules, basically these are linguistic variable. Then you are going to, and then you're going to reduce, or you're going to give some meaning to those variables in the form of fuzzy sets. The moment fuzzy sets means you are assigning certain number, those numbers will going to carry the partial belongingness, right from 0 to 1, including 0 and 1 in between any number. In case of ordinary sets, if it is a belonging, you're going to carry characteristic function or degree of membership 1, otherwise it will be 0. Along with these fuzzy sets, there are few more terms as part of soft computing. Rough sets, you can work. This is also very powerful. People are using in civil engineering. I hope you may be knowing applications of neural network, artificial neural network. Evolutionary computing is also part of your soft computing. Another one is probabilistic reasoning and deep learning. Like that, there are many more topics. If at all you want to see artificial intelligence or soft computing techniques, all will going to come as part of your soft computing. Let's see this statement very carefully. Precision is not truth. Let's assume you have used a sophisticated computer. You have formulated your problem wrongly, even though you are using 500 significant digits. Anyway, computers may not be capable of using that much. Precision is not truth. Please understand. Precision is not truth. We must exploit our tolerance for imprecision. That means you have to respect imprecision. You have a complex problem. You don't know how to solve it. Even though you are solving with little error, please accept and then respect. In that sense, this particular second line, we must exploit our tolerance for imprecision. Let's see, this is a book especially for the beginner. He's a structural dynamics guy. He's a professor at this university. Fuzzy logic with engineering application, right from edition 1, 2, 3, 4, all are available. First edition published by Tata McGraw. That time Indian edition was available. The second and third edition, Wiley Indian. I hope you must have seen this book, red colored books. All Wiley books used to come Indian print, red color. This is the fourth edition. This is available online. This is very powerful book. Please, you can read, you'll understand. Okay, I have taken one slide from that particular book now. This is the 8th chapter. You can see here, fuzzy system simulation. Fuzzy system simulation. You please read this particular statement. Here the one name is there, Lotfi Jadeh. He is no more. 2 years back he expired. He is popularly known as father of fuzzy logic. Please understand. In the 1965, he could able to come up with a paper called fuzzy sets. He published in Control Engineering Journal. Okay, many people have criticized that time. Anything new, people won't accept. Now you can see, especially Japanese have come up with more than 3,500 applications. Now you see, read this statement. As the complexity of a system increases, you please try to understand complexity. How complex is complex for you? It is very difficult to define. If you read and understand a lot, you can get the meaning of this. As the complexity of a system increases, our ability to make precise and yet significant statements about its behavior diminishes. It is quite possible. Let's assume your pandemic. Okay, let's assume every day more than 20 lakh people are getting this disease. We don't know what to do it. But finally you have to solve. No, you are not supposed to allow people to die. Just like that as a government. You can understand the complexity. Our ability to make precise and yet significant statements about its behavior diminishes until a threshold is reached beyond which precision and significance or relevance become almost mutually exclusive characteristics. Then everybody will give up. Okay, every day more than 10, 20 lakh people are getting affected by this COVID. Then what? We have to only pray, God, please come and save us. Okay, one should not go to that extreme. Even there are some problems you can tackle using fuzzy logic. Only thing you have to understand the theory. With this, I'll move to this. Let's see this particular slide. This is basically complexity versus uncertainty. Let's assume you have a less complex problem. You just see basically what will happen. That means your uncertainty is also very small. That is what usually you are doing with algorithms. Present hard computing is capable of considering little complexity. That means y is equal to 4x square. That means x is some data. For x, you are giving some information. Then you will going to construct some rules. Similarly, if you are increasing complexity, basically what will happen? You will going to have the rules. Then you will going to simply based on rules. You will not going to have algorithm. Okay. Don't go by literal meaning of wisdom, what we are using in our Indian philosophy. Okay, wisdom means is ultimate. I want to tell you a little bit. You have a data, you have information, you have a knowledge, and then you have wisdom. Data means it is incoherent. If you give some meaning to data, the process of giving meaning to data is called as analysis. That is what is information. From the information, let's assume you have series of x, you have series of y. If you are able to get some relation, that is what is your knowledge. That is what is your y is equal to mx plus c. Even though it is looking so simple, I have series of x, I have series of y. Then you will going to construct some mathematical. That is what is your organized. That is what is your knowledge. Okay, now we see the relation. Ignorance, incompetent. Let's assume your complexity is so high. Literally, you can think of 5,000 years back or 10,000 years back. What was the situation about knowledge? Complete complexity was there. Complete ignorance was there. That ignorance due to uncertainty. You don't know what to do. Okay. After putting sincere effort, people could able to resolve that ignorance. They could able to construct some models. Simple mathematical model, y is equal to 4x or y is equal to 4x square plus 5x2 square, something like that. Okay. This is how you could able to capture. As of now, we are somewhere here. We are able to understand a little bit about complexity. You could able to get this knowledge and then wisdom. Let's see this particular plot. Okay, input and then output, y is equal to x square. How you have got this knowledge? That means I have a series of data for x and y. I have plotted on this xy plot. Then I could able to see the trend. Okay, I could able to fit this curve. Basically, if you talk anything on xy plane, it is basically curve fitting. This is a specific example of information and knowledge. What is information? If you give some meaning to data, then only it is information. Data as such, it doesn't have any meaning. You have to give certain meaning to data, then only it's going to become information. Then you have another information like a y. Is there any relation between? Now the relation is non-linear. It is basically a power law. That is how you could able to develop the knowledge in a simple one-dimensional relationship. Let's see this particularly. Let's assume I have a knowledge. Okay, how are you going to build a fuzzy system? Fuzzy system means they are very complex. Okay, unless you make certain number of assumptions, you cannot get mathematical models. In mathematical modeling, I hope you know, you have to make a certain number of assumptions. Then you have to make use of certain principles. And then based on certain laws, principles or laws, you could able to get the governing equations for that particular physical system. Whereas in case of fuzzy system, what will going to happen? Knowledge, conscious. Okay, conscious knowledge will be there. Then you have some rules like if A then B. Take for example, I want to tell you one. It may not be the good example. Just in order to make you understand, let's assume someone is jumping from 110-story building. Okay, if you jump from 110-story building, what will happen? You know the result, but you have not performed any experiment. Please understand, this knowledge has come because of the generations. People have said already you must have seen this type of scenes in TVs, or else you must have listened to your friends. That means already that knowledge is there. Then you are going to build the rule. Rule means if A then B. If you jump from 110-story building, you're going to die. That's it. Similarly, you can think of if temperature is 60 degrees, then you have to increase some or decrease some controller speed, something like that. Then you have to construct the membership function. If you construct the membership function for fuzzy number, whatever fuzzy number, triangular or Gaussian or trapezoidal, that means you are assigning some numbers. When you are assigning some number, then you are going to represent your fuzzy system using existing computer. Another way of managing knowledge is subconscious. Usually in the dream, you are going to get sometimes, many things. If you are able to give a mathematical equivalent for those dream, whatever words you are thinking, whatever statement you are making in dream, then it is ultimate. Basically, here you're going to talk about input, output information. Then there are some adaptive methods. Basically, what will happen? They will learn the moment you feed something, how we have learned. That's what I have given that example. Then you will have to have the rules and membership function. Then you can literally attempt any fuzzy system. Okay, another example I want to show you here. Let's assume I have a XY plot here. Let's assume some input fuzzy set is described something like that, low. Okay, and then medium, then high. They may be temperature, low temperature, medium temperature, high temperature. High, anything may be 40 degree and up may be high. You can extend this. 40 degree and up may be high temperature. Then the medium maybe you can say 20. 20 means this is how I have constructed. And then low means any number. Let's assume this number will be there here. Then you can have this line continuously like this. Okay, continuously. Anything this number, take for example, anything 10 and down. Okay, it may be 0 or it may be negative. Then that is low. That means the moment you are here somewhere, take for example, I'm here on this. Okay, this let's assume it's a temperature axis. That means temperature has been described with the set of terms. Those terms are high, medium, and low. This is how you have to, first you have to have a temperature, linguistic variable. Now you have set of terms to describe like this. Then the fuzzy set will going to come in order to quantify. Then you will going to, let's assume I am going to divide this into n number. That means now you see carefully here, I have certain number. If I say it is a 20, let's assume at the central value regarding medium is 20. Now you have here, okay, anything, now you see carefully, anything here you have 20, now let's assume you have 10. Let's assume I have a 12. This 12 number as a temperature, if you draw one line parallel to your y-axis, it will going to cut your medium fuzzy set as well as low fuzzy set. That means the belongingness in this medium is very low. That means it is more towards the low fuzzy set. This ambiguity has to be there. If they are separated out, then you will going to have the deterministic variable. In deterministic variable, there is no ambiguity. If it is 10, 10, 20, 20, 30, 30. Now you see basically this particular 12-degree temperature in this particular set is belongingness is 0.2, whereas in this case it is maybe 0.8. That means it is having more degree of belongingness in the low fuzzy set. But in case of medium fuzzy set, now you can say, take for example here 12 degree. 12 degree anyway is not part of high fuzzy. Okay, your high fuzzy temperature, it is not a fuzzy part of this one because it is there here. Okay, now you have 20 and up partial belongingness, anything 40 and up, you're going to have number 1. That means you can assign 0. In fuzzy set, high temperature fuzzy set, the belongingness of 12 degrees Celsius is 0. That is how you are going to quantify. In the previous slide I have shown, there are different ways of quantifying your fuzzy sets. Then let's assume you are going to process this using some rule base. R1, R2, R3, these are the fuzzy relational equations. In the classical relation also, your classical relations will simply have R. Here I use tilde underscore R1, R2. If A1 then B1, if A2 then B2, if A3 then B3, like that some relations are there for a certain system. Then these are the output. The how we have our input low, medium and high. It may be a temperature or it may be a loading. If at all you want to solve geotechnical example, similarly you're going to get, these are some soil properties. Take for example, you have phi. Okay, angle of internal friction, low, medium, high. Similarly, unit weight, high, medium. Accordingly, you're going to get your settlement or shape bearing capacity or even bending moment, shear portion you are putting and all. Okay, let's see this one practical example. The practical example, how you're going to do it. Especially in order to solve the complex practical exam, you're going to use human experts. Humans are very, very expert. The moment if I make a statement, okay, you can come around 10 o'clock. If you say someone around 10 o'clock, that guy will understand. Okay, that 10 means maybe 5 minutes to 10 or after 10, 5 minutes, something like that. If you say computer around 10, it will not going to understand. You have to quantify somehow. Around 10 means you can have a fuzzy number, maybe starting from even 1050 to 1020. Sorry, 950 to 1020. 950 to 1020. In between, you're going to have 10. Around 10 means you can construct. That means whatever ambiguity is there in his statement, in the human knowledge, that you have quantified in order to process using computer. Then you will going to describe everything in natural language. Whatever we are talking is a natural language. Then you will go ahead and you're going to design, especially your complex control system. Let's assume you have a chemical factory. Let's assume you have very complex chemical process. You have thousands of processes are happening. You want to control. How are you going to control? In the main control room, you have to pass on the instruction to the other guys who are looking after individual processes. Then otherwise, what will happen in Mathematical model? You will going to have a sensory measurement. You will going to measure them literally, and then you will use them. The moment you have sensory measurement, they are deterministic. They are going to have only one value. If it is a low temperature, you're going to have 10 degree. If it is a little high, means 20 or 30 or 40, they are only one. In case of natural language, low means you are telling anything around 10 is low. Like that you can describe. That is how we're going to develop. This is one application of practical system. Now coming to this fuzzy controller, basically this first application of this fuzzy logic in fuzzy controller. Now you see, you have to have certain rule base. Let's assume I have a control application. If temperature is 10, what you have to do using computer? If temperature is 20, what you have to do? If temperature is 40, that means you have to construct the rule base. Okay, this is very, very important. This rule base is also there in the conventional logic. In the conventional logic, you have true or false, 1 or 0. Rule base you have to create. You can have 100 rules, you can have 300 rules. Then you're going to have the fuzzy inference module. There are some inference algorithms are there. If A, then B, you're going to process. Then your input will going to go as a fuzzy set. Okay, here you have to do fuzzification. This is very, very important. You have a fuzzy variable, high temperature, low temperature, or some other temperature. You have to construct the fuzzy number. That is called fuzzification. Okay, and then you're going to process. Afterwards, you're going to get the fuzzy output. In order to give instruction to the controller, finally, you are not supposed to tell high temperature, you do something. What is high? How high is high for you? That you have to quantify. Then based on this rule base, you're going to decide. If output temperature is this much, then you can do this control application, or you can exercise this control application. Similarly, if temperature is this much, you can do activate this particular control application. Then here you have to do defuzzification. Somehow I could able to explain using our geotechnical example, wherein we could able to evaluate the immediate settlement. With this, we will move on to the, this is what is our subject. This is what I used to teach. This is what is the content. Basically, our textbook is your fuzzy logic with engineering application by Ross. That is what is I have given over here. You can just see here, the Ross 2016 fuzzy logic with engineering application. This is the 4th edition. Like that, there are many more. But only thing you have to understand that little bit about discrete mathematics. The lot of videos are available, and then understanding little bit probability. There are certain variables. In those variables, You have randomness as well as your fuzziness. Then you should know how to quantify them. There may be some variables. There are some parameters will be there. They are constant. They're going to take only single value during functional approximation. There are some variables. They may take only random uncertainty. There are some variables. They may be only fuzzy uncertainty. There are some variables you can combine these two uncertainty. There are ways you can go through all these books. You'll understand. These are the set of tutorials. Basically, probability theory is a must in order to understand. Basically, earlier you used to use only probability theory to quantify even fuzzy uncertainty. Fuzzy set operations and fuzzy relations. Like this, we have in classical set operations and classical relations. Fuzzy membership function. Basically, you can use expert knowledge, or else you can ask the expert, n number of experts. You can assign certain weightage to all those expert knowledge. Then you can construct. And then there are some fuzzy arithmetics, like as usual. Then extension principle, fuzzy systems and fuzzy system simulation. This is basically a theory. 1 to 4 are theory. These have been covered from chapter number 1 to 8 in that book. Then fuzzy sets and fuzzy logic in geomechanics, structural engineering, and WRE. Fuzzy sets and fuzzy logic in containment transport modeling. Similarly, seismic hazard analysis. Right now, we are using the seismic hazard analysis. My PhD was also on this fuzzy logic in landslide hazard analysis. Okay, what basically you are doing, you please understand what is really needed as a student in order to understand this particular subject. The course is intended to provide a thorough and fundamental knowledge of fuzzy logic methodologies in a simple, there are n number of ways. How that means there are inference engine. Engine means don't think it is an engine. It is basically like a methodology. If you have a set of rules or rule base is there, we will going to process, and then how are you going to get the output, and then how are you going to defudgify that. Those are called as fuzzy logic methodologies in a simple and yet comprehensive way based on the student knowledge of the basic engineering science. You have to have certain understanding of your basic engineering sciences, then mathematics and basic civil engineering subject. Let's assume I want to use this in geotechnical engineering. You have to understand geotechnical engineering subject, maybe soil mechanics and foundation. Similarly in water resources, similarly in structural engineering, especially in dynamics, especially seismic hazard evaluation, they are using a lot this one. Okay, this is the outline. A few quotes, scope of fuzzy sets and fuzzy logic, and then uncertainty and information. You please this carefully this word: uncertainty and information, ignorance and knowledge. Uncertainty and information, how they are related. Similarly, ignorance and knowledge, even if you count the characters or letters, they're exactly same. A few books, I have just given a listing of the books. All these books are available online. Before understanding fuzzy sets, you have to understand the mathematical model or else finite element. You should know how to get the differential equation. You should know how to establish the function relation between the independent variable and dependent variable. And then in independent variable, if some are random variable, some are fuzzy variable, how to quantify. Once you quantify, you can use that function relations to run, or else you can use a finite element, and then you can run. Then you're going to get output as a fuzzy set. Then you can quantify. Applications in shallow foundation, to some extent, I've already covered as part of evaluation of immediate settlement. Fuzzy logic in geomechanics, especially where you have control. Let's assume you have a structure situated in northeast India. During earthquake loading, I want to bypass the seismic loading at the isolator level. Let's assume just below your footing, you have isolator. Then you have to train your isolator. If you input ground motion is going to come with certain intensity, then accordingly you have to activate your isolator to that means dissipate most of the energy at the isolator level. That means isolator is going to move certain direction in order to dissipate that energy. Only part of the energy will pass through your foundation to the structure. That means that is how you are going to bypass the energy. That is called fuzzy logic. In fuzzy logic, in the sense you have to have rule base. If A, then B type. Fuzzy set means only thing you are going to quantify with the membership function. We're going to simply do the function approximation. Fuzzy system simulation, especially stability of slopes. Let's assume we want to give the early warning system. Take for example in hilly regions. What has happened in 2018 in Kerala, some part of North Karnataka. Recently also something happened. Basically, you have to instrument. Then you're going to get certain geotechnical quantities. Based on that, you can at least issue the early warning so that you can tell the people, please don't use that road. You can put some early warning boards here and there. Then analysis and design of deep foundations and then containment transport people are using, followed by summary. This is the fuzzy set theory review article written by Zimmerman. His book is also available. I want to read only one sentence here. Applications of fuzzy set theory to real problems are abound. Please understand this. Only thing you have to understand is fuzzy sets and fuzzy logic theory. You can literally do many things. I'll tell you one more sentence right in the beginning. If you model your friend carefully, maybe for 1 or 2 months, the moment you give a particular statement to him, you can predict his output. Without he is pronouncing the output, you can literally predict his output. That is possible. You can literally model human beings using this fuzzy logic. Okay. Now you can see this is the first paper as part of my PhD, reliability analysis of slopes using fuzzy set theory. That means reliability analysis require information about uncertainties. This is very, very important. You can see the first statement. The stability assessment of slope is difficult because of many uncertainties. If the uncertainties are only probabilistic, you can use probabilistic reliability analysis. If there are uncertainties, they are related to fuzzy uncertainty. Fuzzy uncertainty means uncertainty due to knowledge. That means I don't have tremendous knowledge. That is the reason. What are you doing in engineering? Using science, some knowledge, we are modeling something. Okay, we want to predict something. Let's assume we want to predict some flood. Maybe 10 years down the line, if the rainfall of intense will going to occur, whether we will going to get the similar flood what we have experienced in 2015 in Chennai or not. Something like that you can think of. Basically, you are doing a lot of predictions. When you want to do predictions, if they are mathematical equations, you can do. There are no mathematical relations. There are no explicit relations between input and output. But somehow we have got that knowledge in the form of linguistic knowledge. Okay, if this is a situation, this will going to happen. This you have to quantify using these fuzzy sets. That's it. Okay, it is yet another application. Possibilistic reliability theory, theoretical aspects and applications. This is applied to structural engineering. Now you see here, rapid visual earthquake hazard evaluation of existing buildings by fuzzy logic modeling. You can go through this paper, all are available. That another one, application of fuzzy finite element method in structural dynamics. Let's assume you have a fuzzy finite element software. Take for example, you have Abacus. You know how to analyze the seismic response of structure, or how to analyze the seismic response of your shallow foundation supported bridge structure. Bridge structure means you're going to have bridge pier, and then you have abutment, then you have bridge deck. That's all. Other things, they are just added beauties. Okay, how are you going to? Whatever uncertainties or input parameters are coming, if they are fuzzy, you have to quantify using your fuzzy set. Then there are some ways how to propagate these fuzzy uncertainties in the system modeling. Take for example, here I have an implicit relation. Simply you are going to use some input to finite element program, then you are asking the finite element to run, then you are going to give some output. Based on that output, you are going to decide whether structure is safe or not. Then here your inputs are not just deterministic. They won't take single value. They are going to take around 10, around 20, around 30, around 20 and all. You have to construct some ambiguity. You have to be very careful. In order to construct, you have to have system thorough knowledge. Then only you can do that. A lot of applications are there in structural dynamics, in earthquake engineering. With this, I'll move on to the codes. You please see this very carefully. Those who don't know fuzzy set theory, they may criticize that. First, you have to understand thoroughly, then only you can criticize. Just see the statement given by Albert Einstein. A theory is something nobody believes except the person who made it. An experiment is something everybody believes except the person who made it. You please see, understand. Another one, nobody ever mastered any skill except through intensive, persistent, and intelligent practice. This is very, very important. Okay, don't expect to become expert overnight. And also, you have to read the right material at the right time. Okay, uncertainty and information. We'll spend a little more time and then we'll move on. Just see basically in the chapter 1 what this guy has given. It also introduces the fundamental idea of set membership, thereby laying the foundation for all material that follows, and presents membership function as the format used for expressing set membership. This is what I have already shown using that one example. The term uncertainty can be viewed as a component of ignorance. Let's assume you have a lot of uncertainties. That means you don't know more about the system. That means that is your ignorance. Taxonomic breakdown of ignorance can reveal many components having a strong association with human cognition of information and knowledge construction, philosophies, and practices. Uncertainty and information as a pair, you please see this very carefully. Similarly, ignorance and knowledge as another pair are tightly interconnected. Even if you count the number of letters are exactly same. Similarly, positive, negative, love and hate, like that English. You see carefully English words. That is how they could able to develop. As the farmer component, you said this is a farmer for this pair. Ignorance is farmer for knowledge of each other pair describes a deficiency in the respective latter. Uncertainty describes the deficiency in information. Similarly, ignorance describes the deficiency in knowledge. While the latter component, take for example, information is a latter component for this, knowledge is a latter component for ignorance. While the latter component of a pair can be viewed as the respective capacity available to reduce the respective farmer component. As and when your knowledge increases, your ignorance will going to come down. That's what we are doing. The wisdom means what? Okay, that's what Indian philosophy is going to do that, right? Okay, now you see some classification about uncertainty. Uncertainty means always it is associated with knowledge uncertainty, like a fuzzy uncertainty. That is the reason this classification. Random is associated with inherent uncertainty. That is there. If you large amount of samples, then you can quantify properly. But you cannot reduce inherent uncertainty. That means random uncertainty you cannot. But this by having enough knowledge about a system, you can literally reduce this uncertainty. Fuzziness, basically what is fuzziness? Lack of definite or sharp distinctions. You can just see there is a overlap between all your fuzzy sets. That's what you have seen. That overlap has to be there. That particular element, it has to have partial belongingness in one set and another set. This ambiguity has to be there. Okay. And then non-specificity is also called as uncertainty. Discord, it's basically choosing among several alternatives when you have disagreement. Okay. In that case, you can call it as an uncertainty. Over the years, how you have modeled all these uncertainty. Even though uncertainty is there, I don't know what to do it. Simply you can use a deterministic, only one value. Young's model is there, only one value. Even though there is certain uncertainty, if at all you want to model a little bit, no, it is not a single value. There is certain uncertainty. You can model using certain range. That is what is interval. People used to use interval mathematics. First is a deterministic value. If you want to disregard the presence of uncertainty, that is first step. People used to do like that. With proper understanding, people went ahead with the interval. That means interval uncertainty. Otherwise, you can go ahead with the probability. That means you're going to have the probability density function information. You can do everything. This is what is given. Deterministic means just one value, even though the uncertainty is there. Interval means certain range. Lower and upper range will be there. Probability distribution means you have everything about that. That means all these variables, basically you are let's assume x1, x2, x3, x4, they are going to vary. This is what is the probability density information. That means this is going to have this much chance of occurrence. That itself is the probability of occurrence. It is coming from the histogram construction. Okay, uncertainty and information. When the uncertainty is going to occur, basically our uncertainty types and all of the things I want to tell you. See the definition here. Let's assume maybe 5,000 years back we had only complete ignorance. Now whatever you have done since 5,000 years to now, that is what is our present knowledge. We want to move towards complete knowledge. That's the reason you have to quantify your uncertainty. Uncertainty may be aleatory, that is what is random. Epistemic means that is related to your cognitance. This is called as uncertainty. That means this uncertainty can be viewed as the difference between the present state of knowledge and the complete knowledge. Once you have complete knowledge means you have complete wisdom. When you have complete wisdom, even though you have complexity, you know what is that complexity. You know how to quantify. That means you are not going to have any ambiguity. That is what is wisdom. That means like algorithms in the conventional computing science. Okay, these are the examples. In the loading, you may have an uncertainty, or else in the boundary condition, you can have or geometric dimensions, material properties, manufacturing imprecision, or imperfect knowledge. Let's assume someone don't know how to use finite element. If you are asking that guy to use finite element software and design particular structure, then comes a problem. That means he has to understand. That means that guy is having a lot of ignorance. You don't know. Then for him, finite element, it looks like a highly complex software. Okay, some examples coming to aleatory. Aleatory is also called as inherent uncertainty or random uncertainty. Adequate statistical data are available in this case if you put a lot of effort. Basically, we are describing this inherent uncertainty using physical system or probability theory. That's what is done here. And then coming to this another uncertainty, that is epistemic cognitive uncertainty. This is also called. Now you can see due to lack of knowledge about a physical system or environment. That means start with there are n number of uncertainties. I don't know how to quantify them. That is how we're going to start with. Basically, how are you going to model this? In order to model this epistemic uncertainty, we are going to use interval variables or fuzzy variables or evidence theory or possibility theory. Probability theory and possibility theory. You can just see your probability theory is a subset of possibility theory. I want to tell you, possibility of anybody becoming a prime minister in India is there. Possibility. What is the probability? Let's assume someone has not contested even corporation election. There is no chance. The probability is very low for that guy, but the possibility will be there. That is the reason this fuzzy set theory is a superset of everything. Okay, the uncertainty can be cropped in the definition of your problem. Let's assume you don't know how to define your problem. While so doing, only you're going to put your uncertainty. Then available information. Let's assume you have very little information about a system. You want to model using that little information, and then what will happen? Basically, you're going to have the uncertainties. Another one, alternative solution methodology. Why n number of methods? First of all, to solve a particular problem, because you are not sure whether this particular solution is applicable or not. That is the reason we are going to try different number of solution technique. And also another one is random nature of the solution outcomes. Sometimes, even though you are going to use the top algorithms, by very nature, you're going to get the different outputs. This particular aspects necessitates the increased reliance on the proper treatment of uncertainty. Okay, these are the uncertainties in geomechanics. Uncertainty is a fact of life in geotech and geomechanical engineering. Nature in its complexity offers soil profiles often different than A and B. Let's assume in one location you have drilled a borehole, then you could able to get the soil profile. Don't expect in another location you're going to have exactly same. That means soil profile A is not equal to soil B. Then loads and environmental conditions likewise defy accurate predictions. Limited sampling. Let's assume you want to get the Young's modulus. of a particular soil. For that, you have taken only 2 samples. From the 2 sample, you cannot get anything. Okay, that is the reason you have to have a large sample. Probabilistic and fuzzy methods provide the means for quantifying and communicating degrees of uncertainty. Please understand this very carefully. Probabilistic and fuzzy methods provide the means for quantifying and communicating degrees of uncertainty. There are many uncertainties. Somehow our engineering design right now incorporates uncertainty in one form or the other. Even though uncertainty is there, as a starting step, you can disregard the uncertainty, consider as a single, that means deterministic variable. You can use that in the functional approximation. Then you can evaluate the output variables. Okay, these are the ways of representing uncertainty. Classical set theory also can be used to some extent. Yes, you can use. Otherwise, you can use probability theory. If at all uncertainty is entirely due to inherent variability, if it is due to cognitive sources, because of ambiguity, because of vagueness, then you can go for fuzzy set theory. If it is a little higher degree of uncertainties, you can go for fuzzy measure theory or rough set theory. What is the specialty about probability theory? Probability theory provides the conceptual and theoretical basis for modeling and analyzing uncertainty. Take, for example, I have a functional relation y is equal to 4x1 plus 5x2, where x1 and x2 are random uncertainties. That means you can use probability theory. You can get the probability density function for x1. Similarly, you can get the PDF for x2. Once you know the PDFs of these variables, literally you can use probability theory. You can get the probabilistic information on your dependent variable y. With that, you can do whatever calculation. Then you can pose a question: probability of y is less than this, or probability y is greater than. Okay, let's assume your settlement. You have got 10 mm. Okay, your allowable is 8 mm. Then what is the probability? If that probability is very less, then you can go ahead and construct. If the probability is high, probability indirectly going to tell you the risk. Okay, if you are able to adjust with that risk, you can go ahead and construct. That is how you can make use of probabilistic information available in the probability theory. Okay, this random word has come around 1565 AD. Okay, this is what is the definition. Similarly, this uncertain, you can just see it is adjective. Around 14th century it came. What is the meaning of uncertain? Indefinite, indeterminate. You cannot model these. In order to model these things, because these are there in the natural language, but I have to quantify. For that reason, the Jade has developed the fuzzy set theory in the 1965. Not certain to occur, problematical, not reliable, untrustworthy, or not constant variable. These are some definitions. Please go through that. Okay, if you classify uncertainty in geotechnical engineering, one is a random, that is entirely due to natural variation. That may be due to variation in time or maybe variation in space. That means X, Y, Z. Then uncertain means it is due to knowledge uncertainty. That means I'm not capable. That means I'm not fully trained. I don't have capability to understand the complexity, especially your parameter values, especially Young's modulus Poisson's ratio. How are you telling they are correct? Based on limited sampling only, you could able to get C pi, gamma, Young's modulus and Poisson's ratio. And it also depends on model choice. Who told you to choose only this model? Who told this model is the best? Because there is ambiguity. Because you know only that model. That is the reason you are using. That model may not be.
Hello. Sir, we are unable to hear you. Hello. Dear participant, just hold on. The expert will rejoin. Maybe some technical issue. Sir, actually, hello. Yes. Yes, sir. I will see. Please, sir. Proceed, sir. Hello? Sir, please unmute, sir. Sir, please unmute, sir.
Yes, I am doing that. I am doing that. Anyway, it is
Okay. Okay, sir.
okay. Now you
Yeah.
can see it's okay.
I'm getting audible, sir, but I'm not seeing any screen, sir.
Oh my God, this also disconnected, huh?
Screen, yeah, you
I
have to share the screen one more time, sir.
once again I have to share. Okay, fine, please.
Yes,
One
sir.
minute. 1 minute.
Yes, sir. Sure, sure.
Share screen. Okay, now you can see
Yeah, it is sharing, sir. Yes, sir. Example,
it
I'm
is coming
seeing
in.
some slide with example.
Ah, yeah, yeah, yeah. No,
Yeah.
earlier I told two kinds of uncertainty. At least they could able to see this slide. No,
Yes, sir. Two kinds of
Girish.
uncertainty.
Earlier they could able to see this. After this only that internet went off.
Yes, it got it disconnected. Yes, sir. Please go ahead from there.
Okay. No, no. These are the two types of uncertainties. Okay. One is due to natural variation. That is called a random. Another is due to knowledge. That is what is uncertain. In order to quantify the uncertain variable, you have to go for fuzzy logic or fuzzy set, whatever. Variation in time and variation in space. Basically, if you talk about C1, C2, C3 at different depths, you're going to have different cohesion values. Similarly, even if you take horizontal plane, you're going to have different C1, C2. That is what, even with the time things degrade. That means properties are going to change. That's what happens to your structure also. Similarly, here model choice. Why are you choosing different model? Okay, these are some different names for uncertainty in the world. Are random uncertainty, aleatory, external, stochastic. This is uncertainty in the mind due to knowledge uncertainty. That is epistemic, internal, subjective. What are the examples with regard to geotechnical or civil engineering application? Examples of natural variation. Take for example a spatial variation of soil properties. Okay, spatially the soil properties are going to vary. See the spelling SPATIL. That means X, Y, Z coordinates. Okay, let's assume you have to imagine you are literally moving inside the soil deposit. You are looking for C5 gamma. They are going to vary. That is what is a natural variation. You don't have any control over that. Only thing you have to collect large amount of samples, then you quantify them properly. Then flood frequencies. Okay, just see this carefully. You don't know whatever information you have so far till 30, 40 years. Using this knowledge, you cannot predict flood. At the most, you can predict maybe 90%, 80%. That is okay. And then earthquake occurrence. You don't know when earthquake will going to occur, where they will going to occur. These are all natural variation. As far as examples under knowledge uncertainty are concerned, parameters of soil engineering property models. Take for example, you have a CC. Compression index is equal to 0.009 in bracket WL minus 10. Who said this is correct? This may be applicable for certain class of soils. But when you don't have anything, that is how we're going to quantify. I know this was given by Terzky. Terzky is going to be a great man. He's popularly known as father of soil mechanics. I am going to use stream rating curves. There are stream rating curves. There is a lot of uncertainty, and then other seismic attenuation. These are also called ground motion attenuation relations. Okay, now we see carefully here. Now you will understand how much is random in the world, then how much is certain. That means deterministic. You have more guarantee, or you can assign only with one number. Then coming to the remaining, that is fuzzy, imprecise, and vague. Our objective. Now we can see with random or probabilistic modeling, you could able to resolve some problems. Then with certainty, that means wherever you have f is equal to 4x square, everything is certain. When x is taking different values, correspondingly your y is going to have different values. When you have fuzziness, imprecision, and vagueness, it is very difficult. That is the reason one has to resort to fuzzy logic, understand the theory, and then quantify and then use. Okay, it is another way of seeing all uncertainties: evaluation data uncertainties, natural uncertainty, model uncertainty, and input data. Especially our input data is uncertain. You please see this carefully. Uncertainty or degree of uncertainty associated with the input data is tremendous. That is the reason one has to put a lot of effort. That means you have to get a lot of data and then collect a lot of expert opinion. Then you have to quantify accordingly, and then you can use the model uncertainty modeling and all. Okay. Then statistician probability, there is some theory. And then these are the sources and types. I want to tell you how are you going to quantify. This understanding is also very, very important. Let's assume you have tested n number of samples. You could able to get unreduced shear strength. In each of the bin, you're going to count the total number. Now you see basically what will happen with this information. What you can do, sometimes you may get a continuous distribution, or else you may get discrete distribution. This is also possible. Now you see basically what I'm going to do. I hope you know, the moment you normalize the number of occurrences in this particular bin using total number of occurrences, you're going to get a relative frequency. Now you have to join these points. Okay, now you see carefully this information. This is how we're going to build the probabilistic density model for the particular data. First, we'll construct the histogram. Then we're going to construct the relative frequency polygon. Then we're going to join these things. Okay, this is the lowest and upper value. Now, depending on this frequency, that means this particular variable, this is a chance of occurrence. Basically, this is a probability density information. Now, you can see here. A histogram is an approximation to the probability density function. Basically, what will happen? Your bin width reduces to 0. That means your delta x, whatever bin width is there, this is going to 0, and total number will go to infinity. As the number of samples tending to infinity and this bin width tending to 0, your histogram reduces to probability density function. This is how we are quantifying. Similarly, same information can be used even in fuzzy. This is the schematic of probability study, how we're going to start with the real world, and then from the real world you'll pick up some samples, then you're going to get histogram density information, then you're going to define certain function relationship, then you're going to evaluate the risk. Risk means probability of occurrence and consequences. Then accordingly you're going to make a design decision whether you have to implement this design on ground or not, or else you can modify something. They can do the same analysis, go ahead and decide. Okay, similarly uncertainty information a little more. I want to tell a little bit about fuzzy here. Now you can see the fuzzy systems are useful in two general contexts. In situations involving highly complex systems whose behaviors are not well understood, you please this understand. That's the reason I have made earlier one statement. Fuzzy logic is not solution to all the problems. In situations where an approximate but fast solution is warranted, I have a very complex problem, I want immediate answer, then you can bring in the human expertise. Somehow you have to quantify using fuzzy logic. Definitely you're going to get a fuzzy output. Somehow you have to quantify that. Okay. See this particular statement given by the Shannon. Information is the resolution of uncertainty. If you see this carefully, there is a lot of hidden meaning is there in this. Information is the resolution of uncertainty. Okay. Information in the sense you're going to collect data first in order to resolve this uncertainty. Then for that data, you are going to give some meaning that will going to become information. And that information will be degenerated into knowledge. Definitely you have reduced the uncertainties. If that knowledge gone up to the wisdom level, then almost uncertainty is decreased to 0. Okay, fuzzy set theory and fuzzy logic, not a competitor but complementary to probability theory. Please understand this. So the guys who are working in probability theory, sometimes they'll think it is a competitor. It is not like that. Both have values. Fuzzy logic is not the solution for all problems. Please carry this particular point. Let's see this idea of membership he gave in 1965. I want to go ahead. Okay, in case of classical sets, it contains objects, means it has to satisfy 100%. One example I want to tell you, already I have given. For example, the set of heights from 5 to 7 feet is precise. That means 5 to 7. That means I have a fuzzy set called height. That is a capital A is equal to 5, 6, 7 feet. 5, 6, 7 feet, whatever number you have. If 5 is belonging, its belongingness is 1. 6 also 1, 7 also 1. If other than if it is not a belonging, then what about 4.9? That question arises. 5 to 7, 5 feet to 7 feet, whatever number you have, they are belonging to your ordinary set. If they are belonging, the degree of belongingness or characteristic function is 1, otherwise it is 0. What about 4.9? There hardly any difference between 5 feet and 4.9. Okay, you can just think of 4.9 and 5 feet. That means there is some knowledge. How can you call it 4.9 is short when you are calling 5 to 7 as a tall? That means how tall is tall for you? There is a relative. That means there is a subjective knowledge in it. How are you going to quantify? Take for example, the set of heights in the region around 6 feet is imprecise and fuzzy. Now you see, region around 6, you can construct using 5, 6, 7. The region around 6, that means 6, no doubt, it is having 1. Anything more than 6 is tall. Okay, 5.9, you cannot call it as a short. That means 5.9, no doubt it is around 6, but the degree of belongingness is not 1. It may be 0.8 or 0.9. That is the reason fuzzy set will going to come into. Now we can see here how to quantify. This is the ordinary set. That means 5, 6, 7. If 5 is belonging, you just see here. Chi A is called as characteristic function. This is mu of h. This is for the height membership function. Now you see here 5, 6, 7. Anything less than 5 is 0. Actually, it is a solid line here. Anything more than 7, it is a 0. Okay, this is what happened. Now around 6, you can construct something like that. Now take for example 5. This is not 5, no doubt it is a membership belong to this fuzzy set H. That means it is a height membership function. The 6 means definitely 1. Okay, because I have constructed around 6. It is not a tall or short, around 6 feet. Now you see, no doubt 6 is going to have 100% belongingness. The 5 is also going to have certain. Okay, but here in this case, anything less than 5 is 0. But now 4.9, no doubt it is a part of this fuzzy set. Now it is having a lesser belongingness. That means this partial belongingness will going to give a broader meaning to the linguistic variables you can quantify using. The linguistic variable is your height membership function or height membership. You quantified using this fuzzy set. Now you can take your membership function. Here you can take this alpha cut. There's one term called 0.2, 0.4. Then you're going to get the so many function values. Then you can use this in the function approximation. Okay, that is what is given over here. In case of ordinary sets, this is how we're going to use. If X is belong to A, then it is 1, otherwise it is 0. Like your 5, 6, 7, all are belonging. Their corresponding chi A function is 1. This is what is given over here. Now coming to the fuzzy set, ZA extended the notion of binary membership to accommodate various degrees of membership on the real continuous interval 0 to 1. That is what is you have seen the membership function, where the endpoints 0 and 1 conform to no membership and full membership respectively, just as the indicator function does for the crypt sets. But where the infinite number of values in between endpoints can represent the various degrees of membership for an element X in some set on the universe. The moment you say any set, take for example set H or set A, corresponding universal set has to be there. Please understand that. Without that, you cannot do anything. This is what I already told. The moment you say in even ordinary set theory, any set A, B, C, corresponding universal set. Take for example set C, that is a cohesion set, corresponding universal set has to be there. Means all possible values are there. You may take part of maybe 10, 15, 20. Then all values will be there. Similarly for Young's modulus, similarly for Poisson's ratio, that has to be there. That is the meaning of this consideration of inverse of discourse or universal set. Now this is how we're going to represent. The membership function embodies a mathematical representation of membership in a set, and the notation used throughout in this particular text is a fuzzy set, is set symbol mu A. A is an ordinary set or classical set. The moment you use this underscore tilde, mu A underscore tilde of X is contained 0 to 1. It is a closed interval. 0 means it's not going to belong, 1 means it's going to belong, where this symbol is the degree of membership of element X in fuzzy set A. Therefore, mu A of X is a value on the unit interval that measures the degree to which X belongs to fuzzy set A. Equivalently, mu A of X, degree to which X is contained in A. You just see this is a number varying from 0 to 1. This is X is a set element that is in fuzzy set A, degree to which, whether it is having 0 degree or 0.2, 0.3, 0.4, 1. Either you express in terms of percent or else you can express 0 to 1. That is mu A of X. That means you are going to tell a particular number. Let's assume mu A of 10. What is its degree of belongingness? Maybe 0.1, 0.2. That is how we're going to describe. This is the difference between classical and fuzzy set. Okay. Fuzzy sets are sets whose elements have degrees of membership. I hope you can understand at least for the time being now. Fuzzy sets are sets whose elements have degrees of membership. 0 to 1 in between any number. That depending on how many intervals you want, you can divide that many number. Fuzzy set theory permits the gradual assessment of the membership of elements in a set. This is described with the aid of membership function valued in the unit interval 0 to 1. Then how to distinguish between randomness and uncertainty? Please go through that. There is no time. I want to show a little more. Now you can see here carefully the fuzzy set. Let's assume I have a membership function. Non-fuzzy set, it is a cool. Okay, whatever temperatures you have, these are degree Fahrenheit. 50, 60, 70 degree Fahrenheit means it is a air temperature. This is called as a cool. You can just see this carefully here, cool. That means even 60 also cool, 70 is also cool. How it is possible? Okay, in natural language, if you express using ordinary set, then comes a problem. Okay, 50 cool is okay. Even 70 is also cool. 20 degree difference will be there. In order to quantify or in order to make it more meaningful, if you consider the fuzzy set for this cool, now you see basically what will happen. Okay, 50, 60, 70, no doubt. 60 is cool, I have defined here that the belongingness is 100%. The 70, you cannot call it as a cool. Then what you are going to take, no doubt it is the element of this fuzzy cool set. 70 is degree of belongingness is 0. Similarly, 50, anything less than 50 is very cold. It is a cold. 50, 40, 30, 20, it is a cold. That means it has to go. It is having membership in another set. Okay, that is how you can define. This is a must. This is how you have to, then you have to have certain overlap. This is a cool fuzzy set. Now you see any element 50s or 55, 60, 65, 70, the degree of belongingness is gradually varying. Now you see carefully what anything less than 50 is totally 0. Okay, now you see here, whatever elements are there, they are not belonging to this fuzzy set. That is the reason membership is 0, but they are part of not cool. You can just see carefully. Not cool you can define as a cold. This is what is inherent in the natural language. There are many ways of describing. Not cool means cold. Then if you are going left side, you can have a cold, very cold. Then accordingly you have to choose. Then you're going to go the negative number. Not cool, just see carefully here. On either side, not cool, you can go here warm, hot, very, very hot. That is how you can quantify. Only thing you have to have this overlap. This ambiguity has to be there. Let's assume I have a number here. Take for example, it is a 52. 52, no doubt it is a belonging to cool fuzzy set, but its degree of belongingness is very small here. The moment if you see belongingness of this one in the not cool set, you can just see this carefully here. What will happen? You have degree of belongingness is maybe 70%. That means it is more in the not cool set, but it is less in the cool set. This ambiguity has to be there. Accordingly, you have to make a decision whether to consider this particular element in the not cool or cool. This ambiguity has to be there. Humans are very strong in modeling. Now you are forcing computer to understand this. That is what is artificial intelligence. Okay, the same thing. Now you can see here, it is a forest, bird view of forest. This may be a trees. Now you have A. So let's consider, is location A in the forest? By seeing, you can make yes. Is location B in the forest? Anyway, it is much outside. You can say no. Certainly yes and not are possible. Is location C in the forest? Now you can see here. Maybe yes, maybe not. Because basically forest is more here. Forest, whatever extension is very less here. That is the reason you are going to make. Maybe yes, maybe not. How are you quantifying this? It depends on the subjective, that is vague opinion about the sense of the word forest. Okay, this is what very careful. Please understand this part. Is location C in the forest? Your answer may be yes, maybe not. It is possible. That is acceptable in natural language. That is how we are processing knowledge in natural language. It depends on a subjective opinion about the sense of the word forest. Okay, now we'll move on. Fuzzy sets. This is very, very important. Operations on classical sets, fuzzy set operation, and fuzzy relations. After this, you'll go into how the fuzzy logic, then fuzzy system. This is very, very important. I'll quickly run through. Universe of discourse or universal set is a must. You have to have corresponding. The moment you draw any set, corresponding universe should be there. The moment you are calling a good behavior set, this good behavior has to come from the universal, super universal good behavior set. Then only you can relate one to one. These are some terms associated with the set theory, sets, elements, discrete, continuous, empty set. There's some more definitions. These are some terminology. X belongs to X, X belongs to A, and then X does not belong. Similarly, contained, fully contained, A implies B and all. Anyway, these have been the union, intersection, and all have been. These are the operations. A union B means X such that X belongs to A or X belongs to. Union means it is or. Intersection means and. That means that element has to be there A and B. Only you pull out the common. That is what is intersection. Similarly, complement, difference. Same thing you have to operate on the fuzzy sets. These Venn diagrams. Okay, these are De Morgan's. Whenever you are not able to evaluate this particular A union B, if you are able to do this, you can make use of these De Morgan laws. Then similarly, there are properties of classical set theory, commutative, associative, distributive. Then few more theory, idempotency, identity, transitivity, involution. Then operation. These are the operations. How are you going to perform? These are called as the function theoretic forms. You please this carefully. Set theoretic, whatever you have seen, these are set theoretic form. Theoretically, you are doing. You are not doing any experiment. On computer, conceptually using brain, you are doing. There is a reason set theoretic form. Now you are going to use the functions. Chi-A stands for the characteristic function. Now you see how are you going to get this belongingness A union B. If you use these functions, theoretically you can operate maximum of this. You can get the membership function, get the membership function. Anyway, 0 or 1 will be there here. That's all. You will get 0 and 1. Maximum of this you can assign. Similarly, here minimum, maximum operations will be there. Complementation means 1 minus of this. Similarly, contain means this one. Then you can go ahead, you can look for fuzzy sets. Now you can see basically what will happen. X is universe of discourse. Now you see carefully here, diagram for a crisp set boundaries, A and then B. Now you have some ambiguity here, C. Basically what will happen? As far as your classical set is concerned, C is not element of A. As far as fuzzy set A is concerned, A is an element even in case of classical set as well as fuzzy set. B, no doubt it is not part of even this A or A tilde, but C is a part of fuzzy set A with a partial belongingness. There is no question of C here. There is no partial belongingness. Either 0 or 1 is possible here. This ambiguity, okay, whatever you are told about that A, B, C, whatever forest you have seen, is C is inside forest. Maybe no, maybe yes. For that reason, that means C is having the degree of belongingness very less in this fuzzy set A. A is 100%. Like that you can quantify. That's what has been done here. Okay, fuzzy set A, this is how. You can use triangular fuzzy number. Once you construct, this is called as a triangular fuzzy number. The number means your numbers. Fuzzy logic, in order to quantify, you're going to use the fuzzy sets. Then in order to process this fuzzy uncertainty, you're going to use a fuzzy number using this membership function. That is what is given over here. Fuzzy set is a set containing elements that have varying degrees of membership in the set. You can count here all these elements. X may be 10, 15, 20, 21. You draw line parallel to your y-axis. You're going to cut this function. Accordingly, you're going to get the partial membership. In ordinary case, either you have 0 or 1. In case of fuzzy logic, you're going to have this partial belongingness. Then you can divide for fuzzy set A, B, C. A may be cohesion, B may be your angle of interpolation, C may be your unit weight. Then you can cut 0.2. This is called as alpha cut. That means you're going to get the functional evaluation points. That means you're going to get upper bound, lower bound, upper bound, lower bound at different alpha cut value like 0.2, 0.4, 0.6. Then you can use, depending on your functional relationship, you are going to approximate. That means you are modeling ambiguity. That's it. Ambiguity is there. As a human we can understand, but computer will not going to understand. That is the reason you have to translate into fuzzy sets. And then how are you expressing fuzzy set? If it is a discrete, you can express like this. This is not an addition like in arithmetic. This is an element x1, x2 corresponding membership function. Okay, this is a discrete fuzzy set. They may be 1, 2, 3, 4. What is its degree of belongingness corresponding to x1? Similarly, if it is a continuous, more than 40 degrees high temperature or hot. Okay, temperature you are describing using variables, fuzzy variables like hot. Anything more than 40 degrees Celsius is hot. Then you can describe. You can say 40, 41, 42, 43. Anyway, it is going to have 1. The moment you have 38, degree of belongingness will be less. For continuous fuzzy sets, you are going to use this symbol. It is not integral symbol. Just for notation purpose they are using. Now I can show you one example. See, fuzzy set A. These are all elements belonging to fuzzy set A. See here, 1 belongingness is 0. And then 2 belongingness is 1. 3.5, 4.3, 5.2. Discrete. Similarly, B fuzzy set. This may correspond to some terms in our engineering. It may be cohesion, it may be something, or it may be a rainfall intensity, or it may be rainfall duration, it may be a porosity, it may be something else, or it may be diffusivity, it may be permeability. Function relationship, for that you have to have a specific, that means discipline specific understanding. This is a mathematics. That's all. It's actually mathematical subject. Whatever you are giving, simply I am correlating. These are the terms associated with your fuzzy sets. Okay, union, how are you doing? These are the function theoretic form. Now you see, this is what is your maximum. Basically, you have to compare A and B. You want to take the union, fuzzy set union. You put their membership function, then compare them, take the maximum. Okay, that is what is union. Here in this case, minimum. This symbol stands for maximum. This symbol stands for minimum. Complement means 1 minus mu A of x. You know what is mu of x? The moment you have a set A, corresponding elements will be there. Now I want to get the complement of B. Now you see carefully here, 1, 0 is there. Then 1 minus of that one. Similarly, you want to get the complement 2, 1 minus 0.5. Then the 2 belonging to this particular complement with 0.5. Like that you can do it. This is what is the your Venn diagram, especially for the fuzzy set operations. Is a union. Now you can see common one you are going to write. This is applicable. Whatever you have seen for classical, this is exactly same. Only few rules are not applicable in case of fuzzy set theory. You can see intersection, only common elements. When you are doing intersection, even though you have a proper fuzzy set, you will going to get improper. At least one element. Let's assume is output. Okay, intersection of these two fuzzy set is output. At least one element should have. Now you will going to get the improper fuzzy number or improper membership function. It happens when you are approximating your function using fuzzy sets. It happens anyway. You have to live with that. And then this is what is your complementation. Complement of fuzzy set A. This is A. Complement of A fuzzy set. Similarly, all you can use the De Morgans. These are all applicable. But only thing, these two are not applicable. You can just see A union A complementation is universal set in case of ordinary sets. And then A intersection A complementation is null set. This is possible there. But whereas in this case, especially in fuzzy set, these two are not applicable. Okay, these are called as excluded middle laws. Okay, please understand this very carefully. Because of partial belongingness, you have to understand not all the laws applicable here, especially this. Rest of the operations are all applicable. Even you can think of here Venn diagram. Okay, for excluded middle laws. And then similarly, this A, all these things have been fuzzy set A, its complementation and all. And then as usual, what you have seen earlier for classical sets, all these are applicable. Okay, A union B is equal to B union A. This is associativity, and then this is a distributivity, idempotency, identity, transitivity, involution. Okay, fuzzy set operations. How are you going to do it? A set is given, B set is given. If at all you want to do the complementation, just you can take it. A complementation, B complementation. I'll leave now tilde onward. Okay, now you see how you have done. Simply go and use those formulas. You can do it. Similarly, A union B, A intersection. Then you can see A given B. This is a difference. Basically, this symbol stands for B. A difference B. That means how are you going to do it? A difference B is defined in terms of this set theoretic form. A intersection B complement. You please see. You know how to get B complementation. You know you got B complementation. Now you can use this here. Then you can, now it is intersection. You can use this formula. Like that you can do it. Similarly, difference B difference A and A difference B. De Morgan's principle are also applicable. Like this, now you have come to classical relations and fuzzy relations. Relations are very, very important. Even in human natural language also you have relations. Okay, you have close relations. He is my close relative. How are you telling? Why are you telling? Because he is closely related. He may be relative of your wife or relative of your mother. Then you have to understand certain term called Cartesian product. Basically, you have sets A, B in Cartesian. That means ordinary set. Then you are simply putting them together. X set and y set, x element and y element. At a time you are putting x1 comma y1, then in another bracket x2 comma y2. Simply you are putting them. Then you will try to see is there any relation between x1 and y1. Similarly, x2 and y2 or x1 and y2. The relations may be there multiple. Then crisp relation, fuzzy relations. There are some specific terms called tolerance, equivalence, fuzzy tolerance, and equivalence relations. Once you know this will now we will going to enter the fuzzy logic. That's all only. Okay, these relations are intimately involved in logic, approximate reasoning. Actually, we are reasoning. Reasoning means ability to think, ability to deduce some information from the knowledge embedded in the data. That is called as a reasoning. Humans are very powerful reasoners. Rule-based system, if you have rule-based, you can use, and the non-linear simulation, especially fuzzy logic, is very powerful. Synthetic evaluation, classification, especially want to classify, and then pattern recognition and control. Relations represent mappings for sets as mathematical functions do. Relations also useful in representing connectivity in logic, especially in logic. You are talking if A then B, you have to connect them. Else C. If A then B is one simple rule. If at all you want to develop the complex rule, if A then B else C, something like that. Okay, let's see how are you going to do. This is a definition of Cartesian product, especially x belongs to x and y belongs to y. This symbol is missed now here. X into y, it is not a literal arithmetic multiplication. The Cartesian product of two universes is determined. Simply you have to put the elements x comma a, then think of relation. That is what we have done here. A set, B set defined here. So far we are discussing only classical sets related things. A into B, B into A into A square. You put 1 second here, you can put them. Basically you are putting them in the pair form. Okay, then that's what you have done. This is by definition. X into A is equal to x comma a, such that x belongs to x and y belongs to y. Now you see here basically how you have done. X and y belonging means you are going to get 1, otherwise 0. See this very carefully. This here multiplication is not belonging to x, y, then it is 0. Okay, then crisp relations, similarly you have to establish. Now you see here, I have a set A and B. Now I want to establish the relation matrix. I know what is matrix. Simply putting the numbers in rows and columns. Now A, this is set X, elements are 1, 2, 3. Similarly, I have a set Y, elements are A, B, C. Now elements of X are related to all the elements of Y. That means a strong relation. This is a crisp relation because either 1 or 0 are possible. Whatever degree of belongingness you have seen in classical sets, 1 or 0. Basically, it is called as a characteristic function. In case of fuzzy set, it is called as a membership function. You have filled in 1 to A relation is there, 1 to B is there, 1 to C. This is called as a segmental diagram in classical set. 1, because it is a classical relation or a crisp relation. That is the reason 1. If they are not related, it will be 0. Okay, these are few more terms: reflexivity, symmetry, and transitivity. Now you can see here, I have taken another set X, 1, 2 as elements, Y, A and B as elements. Only 1 A, 1 B is not related. If you want to construct, you are going to get a relation matrix, something like this. If you see the fuzzy relations, you are going to get 1, 0, and then less than 1 also possible, even higher than 0 also possible, because we have a degree of belongingness. Mathematically, one can define relation. Relation is fully contained in X into Y. It is a Cartesian product. You can establish the relation. That means 1-to-1 element relation will be there. This is how we are going to define the relation. Basically, strength between the relations or between the elements. Then the cardinality. Actually, this is what is a cardinality. Whatever number of elements are there in the X, whatever number of elements are there in Y, simply multiply. That is called as a cardinality. In case of ordinary, with respect to cardinality of power sets, okay, this is what is your power set. 2 raised to nx into ny. Okay, npx here. P is a power set. Np of xy. X into y means it's a Cartesian product. You will go to get that means that many number of elements are possible. That is the meaning. Now you can do all these on. Now you have defined the relations. Define R and S as two separate relations on Cartesian inverses X and Y. That means X and Y are universal sets. From the X you can get hundreds of sets. Similarly, from the Y you can get hundreds of sets. You can establish between A and B is a R, B and C is a S. See, A and B set relation is R. Similarly, B and set relation is S. By knowing R and S, can you get A to B or A to C relation? A, B, C sets have been taken from X and Y. Okay, can you establish the relation? That means A to B some relation, B to C some relation. By knowing these two relations R and S, can you get any information from A and C or between A and C? For that reason, you have to understand the relations. The following function theoretic operations for the two crisp relations, whatever you have seen for individual sets, you can do exactly on the relations. You can do. Actually, it is a null related things. You can see here what you have defined. Null and complete relations as the relation matrices O and this is a null relation. This is what is a complete relation. This is what you have seen. You have to define like a universal set. Okay, universal set and then your null set like that. This is a null relation. It is a universal relation. Now you can see how are you going to. Now these are the functional relations. If at all you want to get R union S, you know what is R? R is a relation between A and B. S is a relation between B and C. If at all you want to do this, you may get some information between A and C. That is the reason you have to do. Okay, now how I am going to define? This is what is the union of these two relations. Similarly, intersection, complement, containment, identity. Like that, you can go ahead. And then the composition. Now another relation is going to come. How are you going to use? Basically, you establish the relation. This is what earlier, whatever number you have seen, 0 and 1 in R matrix and S matrix, you know how to get those number. This is how. Basically, you have to play with your degree of belongingness, either 0 or 1 in case of classical relation. Then how are you going to get? What is the importance of knowing relations? What is this composition? It is operation. Let R be a relation that relates or maps elements from inverse X to Y. See this carefully here, X to Y. And let S be a relation that relates or maps elements from inverse Y to Z. Now see carefully here. X to Y is R, S is Y to Z. We can find a relation T, another relation that relates the same elements in the inverse X that R contains to the same elements in Z that S contains. Such a relation can be found using operation known as composition. Okay, this is, now see carefully here. I have a X, I have a Y, I have a Z. I know how to get the relation between X and Y. Similarly, Y and Z. Then by using this composition operation on R and S, I can get some information between X and Z. That's what you have to do. This is R, this is S. Basically, you can simply join them. How they are connected, you can extend. Now you can give the relation. You can use that R union S or whatever operation. Now you see, this is what is your composition. T is equal to R composition S. This is how you have to. How are you going to get the matrix part T? This is how you have to operate. This is a max-min operation. Now, this is a maximum. First, you put them all, whatever values. You maybe 2-3 combinations will be there. Then you look for minimum, minimum, minimum. Among all these, whatever minimum, which is maximum, that is the answer for this. That is how you have to operate. This is called as a max. Okay, max min and then max product. There are two ways of accomplishing this particular operation. One is a max min. This is called as a max min. That means is a maximum, it is a minimum. Another way is called as a max product. This is also called as a dot product. I hope you know in the vector calculus. Now you see basically what you have to do. You have to multiply these, keep them, because you have so many number of elements X, Y like Y, Z. Then you can take the maximum. Max product, max min. Same thing you have to use simply underscore tilde. You will go to get the fuzzy relation and fuzzy composition operation and all. So R and S are there. By knowing R and S, you can get these T, simply making use of this particular formula. Most of the times you are using max min product, max min composition operation. Similarly, you can go ahead and then get the fuzzy relations. Relations are intimately involved in logic, approximate reasoning, rule-based system, non-linear simulation, classification, pattern recognition, control. This is what I already said. There are only 2 degrees of relations between elements of sets in crisp relations. That is completely related or not related. Completely related means 1, not related means 0. Fuzzy relations are then developed by allowing the relationship between elements of 2 or more sets to take on an infinite number of degrees of relationship between the completely related and not related. Now you can see fuzzy relations, how we're going to do it. Fuzzy relation means you're going to have mu r xy. Okay. Now you see how I'm going to do this. Exactly same union. First you consider the relation between R and. Let RS be fuzzy relations. Tilde is there. You please see. This is the difference between the classical relation and fuzzy relations. And the Cartesian space. Product as such is same. Inverses are same. Whatever universal set you are using in classical set and then the fuzzy sets, they are same. Because inverse is same. Okay, this classical set and fuzzy set are different. Then the following operations are applied for the membership values. How are you performing this? Now you can see here membership functions have come. Okay, this may be 0, 1 or some other number. Maximum of whatever number, that is what is your union. Similarly, intersection, complementation and containment. And then you see, this is what is the problem with our fuzzy set. These are not applicable. That means whatever you have seen in ordinary, they're going to satisfy, but here you are not going to satisfy. Okay, as in the foregoing discussion, the excluded middle law or axioms for fuzzy relations do not result in general the null relation and the complete. Null means 0, 0 will be there in that matrix. Full means 1, 1 will be there. Okay, now how are you going to do the fuzzy Cartesian product? Now you see carefully, A cross B. Okay, these are fuzzy sets. Now we're going to get the fuzzy relation. That means it has to be contained in X and Y. There is no tilde here. Please see this very carefully. These are the universal sets. Universal sets are same. How are you performing this? Now you see mu r xy is equal to R is what? R is A into B. It is a product. The fuzzy Cartesian product. This is a fuzzy Cartesian product. How are you getting the member of degree of belongingness? Simply you have to get from A and B, compare them, you get the minimum. That is what is your mu r of xy. That is how I'm going to get the fuzzy relation. Then fuzzy Cartesian product and composition, you can just see here A and B. A into B is a fuzzy relation. Now you can compare X and Y1. This is X1, Y1. You are not supposed to compare the element values. You have to compare the membership belongingness. Now, what is our formula here? Minimum of these coming from X, coming from Y, or coming from fuzzy set A, coming from fuzzy set B. These are the elements like X1, Y1, X2, Y2, X3, Y3. You compare, you can just see here, X1, Y1, you compare, which is minimum? Minimum is 0.2, you have put. Similarly, compare X1 and Y2, which is minimum is 0.2, you can put it. That is how you have constructed. There is a lot of meaning in that. These are needed in order to use fuzzy logic. Before going to fuzzy logic, I am telling the reverse way. We have started from the fuzzy set, and then fuzzy relation, and then fuzzy logic. This is what is your fuzzy composition operation. They exactly same except difference is underscore tilde. Now you see this is exactly same. Max min or max product. You can use exactly same thing. Only thing these are 0, 1 and in between any number. That is how you're going to get your T is a fuzzy composition. But this is not equal. In case of the classical relations, this is equal. But in case of fuzzy composition, it is not equal. T is equal to RS and the sum. Okay, now you have X, Y and Z. Now we have got R and S. How are you going to get the relation between X and Z? That's what you have to do it. Mu T, okay, you are going to get it. And similarly, mu RS, you can do it. See here, secretarial diagram, X, Y, Z. These are the elements of universal set X, universal set Y. You can say fuzzy set A, B, C, you can think of. And then C, this is how I have got T. Okay, now you see how you're going to fill in. Now you can see here elements. If a degree of belongingness, these are the elements. Degree of belongingness is not 0 or 1 in between any number. 0 is also possible. 1 is also possible, and then you have other partial degree of belongingness. That means you are going to accommodate more knowledge when you are carrying out fuzzy composition operation. There is one example given. If please go to this, you'll understand. P and S are given. How are you going to establish the relation? This is how we can establish a relation. Now you can see here. Okay. Similarly, one more example is there. You can carry out. Let's assume you have got some other information P prime. Earlier you have only P information based on certain understanding about the system. Later you are updating this information. Once you update, this is going to become P prime. Okay, with that P prime, how are you going to get the composition operation? That's all you have to do. As we have seen for classical relations, these are all applicable here also. This is a reflexivity, and then symmetry, and then transitivity. Then tolerance and equivalence relation. Once you know that what are these tolerance and equivalence relations, basically you're going to get, whenever you are going to satisfy this one, these are all transitivity, all these relations. See this very carefully, how I'm going to operate. Chi or xi equal to 1 means it is a reflexivity. Symmetry means this is what basically, and then this is a transitivity. Please, and then crisp relation. Now you can construct, you have already seen this R as a crisp relation. If you are operating n minus 1 time, you're going to get back R. See this very carefully, please. This is one of the relations. Okay, you please understand. A tolerance relation R. Earlier you have simply seen the relation. Tolerance relation R, also called proximity relation on inverse X, is a relation that exhibits only the properties of recapacity and symmetry. This is how a tolerance relation R can be formed or reformed into an equivalent relation by at most n minus 1 composition. Basically, you are operating n minus 1 times, you're going to get R. That's a relation called crisp relation. Similarly, you can evaluate for fuzzy tolerance relations. That's what is given over here. Fuzzy tolerance and equivalence relations, reflexivity, that is mu R xi. Similarly, symmetry means both are equal. Symmetry means anyway we know ij is equal to ji. Transitivity means you are going to go in the loop. Okay, the properties of membership function, fuzzification, defuzzification. I have explained to some extent this one. Properties of membership function. If you are defining a set, proper fuzzy set, at least one element should have 100% belongingness. Then what is fuzzification? What is D? This is what lambda or alpha cuts. That's what I was telling along y-axis. You have to mark certain divisions. Then you have to get this functional find and defuzzification, and then fuzzy logic. This is what is that chapter number 5. Fuzzy logic. Before that, you have to understand classical logic. Then comes a fuzzy logic. Once you understand fuzzy logic, fuzzy systems will going to come. If you cover up to fuzzy systems, that means chapter number 8, you can do. Okay, you can just see. Fuzzy logic is a form of multi-valued logic derived from fuzzy set theory to deal with reasoning that is approximate rather than accurate. In classical philosophy, if at all you are reasoning, basically you're going to reason yes or no type, true or false. In contrast with crisp logic, that is two-valued logic, true or false, 1 or 0, where binary sets have binary logic. Fuzzy logic variables may have truth value range between 0 and 1 and is not constrained to the truth values of classical propositional logic or Boolean logic. Furthermore, when linguistic variables are used, that is what is you are using linguistic variables, these degrees may be managed by specific functions. Fuzzy logic emerged as a consequence of the 1965 proposal of fuzzy set theory by Jade. This is the first paper, fuzzy logic paper. It is available online. Now you can see here temperature, how I'm going to do it. If you understand, you will come to know what is logic. Okay, cold fuzzy set I have defined. No doubt anything this temperature. Let's assume it is maybe a 10 or maybe 5 or minus, or it may be 0. You can say it is a 0 here. And then the moment you come over here, minus 10, and then even up to minus 20, minus 30, it is a cold. Now you see warm, maybe 20 degree. Okay, anything more than 40 degrees Celsius is hot. That means this overlap has to be there. Now we can see this vertical line drawn parallel to the membership axis 0 to 1. Now you see carefully here, it will going to touch here 0, and then you're going to have some number, that means here, and then some number. You please understand your fuzzy logic temperature. Let's assume I want to operate my cooler, I want to operate my air conditioner. Then how are you going to operate based on this linguistic variable? These are some terms. In this image, the meaning of the expressions cold, warm, hot is represented by functional mapping temperature scale. A point on the scale has a 3 truth values, one for each of these 3 functions. The point on the scale, now you see carefully, 3 truth values, 1, 2, 3. The vertical line in the image represents a particular temperature that 3 arrows gauge. This is a particular temperature. See this particular temperature. Anyway, it is not part of this particular set. Anything from here and then it is a 0. Whatever elements are there here in this particular hot, from here onwards, whatever you are saying temperature, it is having membership 0 in this. Similarly here, from here, whatever it is there in this, they are 0. Now you see how to understand. The vertical line in the image represents a particular temperature that 3 arrows gauge. These are the truth values associated. That means 0, 1 or any number. Since the red arrow points to 0, this red arrow points to 0, this temperature may be interpreted as not hot because it is not part of this. Please this very carefully. This whatever this temperature value is going to have a 0, that means it is not part of hot, in then in case can be called as not hot. Not hot may be warm or cold or very cold. Okay, now you see orange color. The orange arrow pointing at 0.2, maybe 0.2 here, may describe it as slightly warm. See this very carefully here. It is, this number is 0.2 in this particular warm position. It is a slightly warm. And the blue arrow pointing 0.8, fairly cold. No doubt it is a cold. Any number here means definitely cold, but it is having 0.8, definitely it is a fairly cold. That means it is toward cold. The moment you increase, the moment you go little up, or you are moving towards left, definitely going to become part of cold with 100% belongingness. This from the fuzzy logic, that means variables, linguistic variables, we're going to define fuzzy set like this. Then we're going to get the rule base. Fuzzy logic means you have to have rule base if A then B. If temperature is 20 degree, now you can see whether it is a part of warm. Okay, if it is a part of warm, what you have to do? Then you have to write the rule base. If temperature warm, then you have to give some instruction to the controller to do this, to do this. That is what is fuzzy logic. Okay, here you are going to have the many valued. That is also reason it is called as a multi-valued logic. Okay, there is some introduction is there. Then classical logic, basically we're going to, this is how we're going to define the truth value. Let a simple proposition P is a linguistic or declarative. See this very carefully here. A statement contained in the universe of elements. Here also, even if you take any word, even if you take any sentence, corresponding universal set has to be there. Proposition P is the collection of elements where the truth values of all the elements are either true or false. That is what. This is what is the association. Truth value associated with your proposition. It is a declarative or assessed statement. Is assigned a value of 1 if it is a true. Otherwise, it is 0. Zeros and 1 are possible. It is called as bi-valued logic. If U is the universe of all propositions, then T is a mapping of the universe U. These are some simple sentences or words. In these propositions to the binary quantity 0 and 1. This is a T such that U belongs to U. Now, what is the truth value associated with this statement? This small u is some word or statement coming from the universal. These are the proposition. What is the truth value associated to u is either 0 or 1 in this. That is what has been done. These are some classical logic operations. Disjunction, this is a symbol. Conjunction, negation, implication, equivalence. Now you will see. Then similarly, you have logical or exclusive or inclusive or and all. Now you see carefully here. Equivalence connectives arise from dual implication. For some propositions, P and Q. Okay, if dam foundation is weak, dam will fail. That is quite possible, right? One proposition is P, dam foundation is weak, dam will fail. If P implies Q, then Q implies P, then P equal to Q. Both dam failed because of what? Because the foundation was very weak. Foundation was very weak. That is the reason dam has failed. Similarly, dam failed here because of foundation. That is the reason both are equivalent. Not necessarily all the time these two are equal. This is called as a modus ponens. The reverse one is called as modus tollens. Okay, these things are there. Classical logic you have to understand. This is how these are also there in classical logic. Same terminology. Now this is how you're going to assign the truth value. Okay, and then see how are you going to perform the disjunction between propositions. Propositions means statements, declarative statement. How are you going to do? P disjunction Q, that means X belongs to A or X belongs to B. You know what is this? Is just like a union type. How are you operating? Truth value associated with the P, truth value associated with proposition Q. You compare them, then you have to take out the maximum. That is what is a truth value associated with this compound operation. Basically, you are combining two propositions here. That is called as disjunction. Similarly, conjunction, negation, implication, equivalence. Now you see equivalence. Basically, what will happen here? P implies Q. That means Q implies Q. That means you're going to assign only. Then how are you going to perform this implication? In order to perform implication, what you have to do? P complement union Q. You know what is this? How to operate this? Then you have to go ahead and follow that one. Similarly, you can go ahead. You can do B difference B and all other things. Some examples are given. Okay. With this, I'll move on to the fuzzy logic. Then you can construct the truth table. This is what is the truth table. Already you know these are the individual propositions. Okay. Not P is whatever P is there, you can assign. Wherever 1 is there, 0 will going to come. 0 is there, 1 will come, because it is a classical logic. 0 and 1 are possible. In case of fuzzy logic, will going to have n number. Okay. You see basically P union Q. It is a disjunction, conjunction implies equivalent. Please understand. How are you going to construct the truth table? Even you want to identify the criminal, you are going to pose the question. Based on his statement, you're going to do a lot of homework. How to identify among 10 guys. Okay, all 10s are suspects. Okay, you're going to pose some questions. Then you will narrow down. Then you will eliminate. Then 2 are there. Among 2, how are you going to eliminate? People are using, especially in criminology also people are using. If you supplement that by fuzzy logic, at least you are more sure so that you can identify the proper criminal. Okay, that is what is the benefit of knowing fuzzy logic. These are the combined operation. Here also you can think of how are you going to get the set theoretic forms. Similarly, if X belongs to A, where X contained in X, A is contained in X, then Y is contained or belongs to B, and where Y belongs to Y, and then B belongs to contain. This is how we can operate. Okay. Similarly, you can see all these. Now, another compound composition. Basically, whatever you have seen, conjunction, disjunction, this is another compound composition expressed in terms of linguistic rules. Means in the language, what we are talking, the way. If A, then B, LC. How are you going to perform? If A is one statement, then B is one statement, then what is LC? Linguistically, this compound proposition could be expressed if A, then B. If not A, then C. This is also possible. See here, if A, then B, and if not A, then C. This is also possible. In classical relation, this is what you are exactly doing. P implies Q. Okay, conjunction, not P implies yes. These are exactly same. The set theoretic equivalent of this compound proposition. How are you going to get information? Basically, you have to construct the truth table. How are you going to do that? If A, then B, LC. Basically, you have corresponding sets. We are talking about the classical logic. A into B, you know what is A into B? It's a Cartesian product. You know how to perform this Cartesian product. Similarly, not A product C, it is also Cartesian product. You perform this first and this. Now you have to take this operation. Then you will going to get this or a relation on X and Y. Please, this you understand. Okay. Similarly, there is Venn diagram has been shown over here. Now you have some tautologies are there. You please understand. Basically, the important are modus ponens. Basically, it is a forward chaining rule based on expert system. Basically, humans are so experts over the years you have got. If you work hard, definitely you're going to succeed. There is no guarantee if you work hard, you're going to succeed. But in reality, this rule has been established. If you are sincere in your effort, definitely you'll do something great. That is called as a monens ponens. Even though you are sincere, you may not. Even though you are putting a lot of effort, you may not pass exam. That is what is your modus tollens. Okay, that means P implies Q. Q implies P may not be correct. Okay, you have to be very, very careful. These are called as a tautologies. The first one is modus ponens. Another one is the modus tollens. Please go through that, how to get and how to operate all these. This is what you can do it here. Not B, union B. Union means disjunction. Implies X. Anyway, they are part of universal sets. Like that, all these operations can be performed on all these. Now, these are the propositions. These are not just the elements. Elements means these are the words or sentences. This is what I told. Linguistic variables, that means you are going to treat them as a fuzzy variables. Once you treat them, then you will going to go with a fuzzy set. Fuzzy set means again you are going to have membership function mu. Finally, you are going to operate only on mu's. Okay, mu's means then you're going to assign some number in the truth table, 0, 1, and in between any number. Okay, this is what is the truth table with respect to modus ponens and modus tollens. You can just start with A and B. These are the propositions with respect to A and B. Now you are evaluating A, B, and all. Okay, similarly, you can get all these operations. There are some contradictions are also there. Okay, as part of research also, you're going to develop a lot of contradictions or controversies. Those things can be resolved. Okay, for that one can make use of classical logic or fuzzy logic. I want to take you to fuzzy logic so that will then some more operations are there. These are all compound operations, exclusive or, exclusive nor. What you are thinking, especially in natural language, especially in logic, they have different meaning, especially exclusive or. This is how you're going to construct. PQ, PXOR, that means exclusive or, that is a symbol. Okay, what will happen? Now you see here, P implies Q, PXOR is 0. Now you see carefully here, what happened? P implies Q means you're supposed to get 1 here, but it is not going to happen. But in natural language, day-to-day language, we will going to imply, but it is not so in this. Okay, Venn diagram. There are some logical proofs you can prove basically using all these compound propositions. First, you can have a individual simple propositions, then you construct compound propositions. There are basically some terms. Then you can use logical proofs to prove something. That's all. With this, we will move on to our fuzzy logic. Then you can do inductive inferences and deductive inferences. All you please read theoretically. You can think a lot. You'll understand. And then there are many video lectures available online, especially machine intelligence subject. It is a computer science subject. They are teaching this particular topic with maybe 4 or 6 lectures. That is more than enough. Okay. Let's assume you have some rule. If A, then B. How are you going to construct? Basically, you're going to get a relation between sets A and B. Something like this. Okay. With this, I'll introduce a little bit about fuzzy. Basically, you are going to operate on this. Okay. Fuzzy logic, you please understand now very carefully. Maybe a few minutes afterwards, I will close. Restrictions of classical propositional logics are n number. Why? Because you have already seen TS, truth value associated with proposition S. Similarly, truth value associated with not S, that is 1 minus TS. Sometimes you may get 1 by 2. This is not possible in case of classical reasoning. That is the reason it's called as a paradox. A fuzzy logic proposition P is a statement involving some concept without defined boundaries. In the previous case, you have definite boundaries, either yes or no, or true or false. Accordingly, you're going to assign 0 and 1. Whereas in case of fuzzy logic proposition, it's basically a statement, a declarative statement or assertive statement, is a statement involving some concept without defined boundaries. Examples, statements describing height or weight or assessment of people's preference about colors. These are fuzzy propositions. The truth value assigned to fuzzy proposition P can be any value in the interval 0 and 1. How we have generalized from the classical to fuzzy set, their belongingness from 0 to 1 in between any number. Here also, truth value associated with your proposition is generalized. Now you see carefully here, represented as a mapping, truth value associated with the fuzzy proposition view. In turn, these all propositions should belong to the universal set view. This is what is a mapping 0 to 1, including 0 and 1. This is a meaning 0 to 1. Fuzzy propositions are assigned to fuzzy set. The moment what you are doing, fuzzy proposition means you're going to call it as a fuzzy variable. The moment it is a fuzzy variable, you have to consider some fuzzy set, triangular fuzzy set or trapezoidal or Gaussian fuzzy set. The moment you say fuzzy set, you're going to have the membership function 0 and 1 in between any number. Now you can get those numbers, then operate on only fuzzy membership function. That's what you have done here. T of P, that means truth value associated with P is nothing but that is a membership function. That's all. That means it's going to have these values. Indicates the degree of truth for the proposition P such that X belongs to A is equal to the membership grade of X in the fuzzy set A. That's all. Now you can see here. This is what exactly we have done so far. Proposition P is assigned to fuzzy set A. That means you have to construct fuzzy set A. For that, some knowledge has to be there. Whatever, depending on the proposition, truth value of proposition TP is given by this. That's all you have done. Where this one indicates that the degree of truth per proposition that's contained in A is equal to the membership grade of X in the fuzzy set A. Basically, you are going to put this one. Okay, then negation, how are you going to do? Disjunction, conjunction. Then now you see carefully how are you doing negation. T not P means 1 minus. Still 1 is ultimate value. Whatever you have got truth value, not P means 1 minus of this. T of P means it is mu not P. You have to substitute here, you will get. Disjunction, you can just see carefully here. Maximum T of P, T of Q. Now what is T of P? What is T of Q? Truth value associated with fuzzy proposition P. Similarly here, truth value associated with fuzzy proposition Q. How are you going to get this? Simply like this. Here you put TP and then TQ, then whatever are there, you put them here, fuzzy membership belongingness, compare, then get maximum. so that you have performed this disjunction. Basically, you are going to perform the compound operations here on the simple Pudgy propositions. Conjunction, implication, similarly, same thing you can do it. Same thing have been given over here. Now you can see here, how are you going to do it? As before in binary logic, the implication connective can be modeled in rule-based form. P implies Q. If X is A, that means X is element coming from Pudgy set A, then Y. Now you are telling X and Y, these are not just numbers here, they are the propositions. If X is coming from Pudgy set A, in turn universal set will be there. Similarly, then Y, that is Y proposition is coming from P Pudgy set, corresponding universe will be there, and it is equivalent to the Pudgy relation or equal to A product B union not A into Y. Recall your previous equation. How are you going to perform? In order to get mu or xy, that means I want to get the degree of belongingness, that I want to fill the matrix or, this is what exactly you have to do here. Not is there here, 1 minus mu A, that's what you have done. And similarly, A minimum and this is a maximum. Okay, you have to put them, compare them, and then whatever maximum that you have to take out, that means you have literally performed this operation. That means we have done here in one example that is given over here. You can just see here. Okay, this is what is given over. Exactly same thing has been given over here. What you have seen here, same thing has been given with the color. This is one example. I have set A, B, C, medium uniqueness, medium market size, diffuse market size. Now you see A into B. How are you going to perform? A into B. Now you can see your matrix. Zeros are there, ones are there, less than ones are also there. Similarly, not A into Y. Now you can see how I'm going to perform. I want to get R. How are you going to get R? This is by definition. It is called as a function theoretic form. Sorry, set theoretic form. What is its equivalent? Function theoretic. This is what is your function theoretic form. That is what is given over here. That means earlier what you have seen is this is what is your set theoretic form. This I want to operate using function theoretic. Basically, these are numbers 0 and 1 in between any number. That's what you have to do it. Now you have got this. Once you have got this, with this you can go ahead with the logic and then relations, Pudgy relations. Depending on these relations, y is equal to f of x, where x is also Pudgy set, y is also Pudgy output. Through this relation, you may have n number of relations, R1, R2, R3, like if A1, then B1, else C1. Similarly, if A2, then B2, else C2. Similarly, if A3, then B3, else C3. Like that, you construct the relation, like R1, R2, R3, R4. You can have n number of Pudgy rule. That is called as a rule base. Pudgy toolbox is there, very powerful. In MATLAB, you can read the manual. There are some example problems are given. Okay. And then this is basically we have performed this one only. Now you not A, product C. This is what you have to do it here using this. Now you can see here, if X is A, then Y is B, else C. This is how we are going to operate. Basically, what are you doing here? We're going to operate on the Pudgy membership function. From the Pudgy membership function means you have Pudgy set. Pudgy set means you have Pudgy variable. Pudgy variable means you have proposition. Proposition means words. Okay, now you understood words. Pudgy logic is computing with words. As such, it is not possible to use words using the present computers. Present computers are very powerful, manipulating the numbers, what I have given over here. How are you going to get? You are going to reduce the knowledge embedded in the words and sentences through Pudgy sets. Then the Pudgy sets, you have some terms called Pudgy membership function. And then all these operations you are going to perform. These are mathematics basically. Mathematics means you don't have to think other alternative. You have to learn, you have to understand. Once you understand, then you can do all these things. This is just a cakewalk later on. Okay, that's what you have done. Finally, you have got this relation matrix. These are Pudgy relation matrix. These relations have tremendous applications, especially in approximate reasoning. The ultimate goal of Pudgy logic is to form a theoretical foundation for reasoning about imprecise propositions. Imprecise. Old men are wise. In the classical logic, you can do something. Very old men are what? That you don't know, na? Old men only you know how to quantify. But very old. But in case of Pudgy logic, you can quantify. Even you can quantify very, very old. If you are able to quantify old using some Pudgy set, very old also you can do. Basically, these are the modifiers. These are called as linguistic edges. Such reasoning has been referred to as approximate reasoning. Approximate reasoning is analogous to classical reasoning for reasoning with precise propositions, and hence is an extension of classical propositional calculus that deals with partial truths. Here we are talking of partial truths. Okay, maybe 90% is also okay. Even if you are not able to get 100% exact results, even if 90% you are getting, it is okay for complex problems. Instead of getting no solution, at least you are going to get some solution, which is 90% of them acceptable. That's the reason for complex problem, one can use this Pudgy logic. Okay, again is a rule base. If X is A, then Y is B, where A and B represent Pudgy propositions. Similarly, if X is A prime, then Y is B prime. Consequent B prime. This is how we can get. This is composition operation. There are some examples given over here. You can please just have a look so that you'll understand. Some more examples are given. Please, you can just, it is just a mathematical application. Whatever needed in order to have some understanding for the beginners, I have given enough. You can supplement this with NPTEL lectures are available. More than 20 faculties have given video lectures on YouTube. You please go through that. Then you can supplement your reading through this book and some papers. Then here also we have fuzzy tautologies, contradictions, equivalence, and fuzzy proofs. Similarly, you can construct the truth table. Now you can see the numbers. Earlier in case of partial table, you have got only zeros and one. Here you have got partial belongingness. How can these numbers be interpreted? Here you have to have some intelligence. Okay, these classical guys will hate this. What is this 0.8? You tell deterministically how to get this number. Okay, the classical proportional logic guys may not like this, but it is having a powerful applications. Okay. Similarly, other forms of implication operations are there. There are many more. People are coming up. This field is so vast. Many developments are taking place. Even many new applications are coming, especially in case of war, how to control your, especially fighters. Okay, sitting on ground, how to control those applications people are developing. Especially these type of works are happening in NASA. Only thing our people should do something in order to protect our country. These are some other forms. That's what I have given. Fuzzy systems. In the fuzzy systems, you have to understand. Very important thing. Already you have seen natural language. Basically words and sentences. Linguistic hedges means your modifiers. Rule based, these are canonical rule based are there. Decomposition, likelihood, aggregation. Graphical techniques of inference. This is what is called inference engine. There are Mamadani. There are so many are there. You please go through onwards from here. That's what this logic, proposition, and all other things are there. Fuzzy system simulation. You have to understand fuzzy relation equations, non-linear simulation, and fuzzy associative memory. It is also fuzzy inference engine. Okay. Now you can see this very carefully. Whatever I have said to so far in order to summarize, but there are limitations. There is no idea or proposition in the field. In the field, in the sense, whatever the existing field means, the world, which cannot be put into mathematical language. Any idea or any proposition, anything you think in natural language, anything you express in natural language, that can be expressed in mathematical language. That means you can quantify using mathematics. Although the utility of doing so can be very well doubted. As of now, some doubts are there. Maybe further research, if you continue in this field, definitely you can literally resolve all complexity. That's it. Definition of fuzzy, once again as a revision: not clear, distinct, or precise, blurred. Definition of fuzzy logic: a form of knowledge representation suitable for notions that cannot be defined precisely, but which depend on their context. This is very carefully. Very good. Maybe it is a relative. I may be good in some situation. I may not be good in all the situation. How are you going to model the human behavior? Especially in case of human behavior, people are using, especially in organizational behavior, all those things, especially management, people are using a lot. Okay. That's it. There are few books. This is what I was telling. Start with, you have to understand linear algebra, and then little bit about fuzzy calculus, fuzzy differential equations are there. Okay. This is another book. It is also best book. He's a water resources guy. Okay, if at all you want to do something more in water resources, please read the papers written by this Buckley. Okay, an introduction to fuzzy logic and fuzzy systems. It is yet another book by clear computer science guy. Okay, this is again computer science book, logic and discrete mathematics. The video lectures are available. You have to understand discrete mathematics. Basically, it is a logic. Okay, uncertainty, rule-based fuzzy systems, and then you have fuzzy system engineering, and then you have again simulating fuzzy systems by again Buckley, and then these are civil engineers. You can just see structural engineers. N number of structural applications are described in this particular book. And then this is again structural dynamics guy, Moeller and these two, fuzzy randomness, uncertainty, civil engineering, and computational mechanics. Then fuzzy logic in hydrologic modeling by Jakaisen. And then uncertainty, risk, and uncertainty in hydrologic systems. Similarly, neural network and machine learning, you can have it. Computational intelligence. These are some books. Fuzzy sets in geomechanics. That means what I have said. Whatever applications in shallow foundation, evaluation of settlement or bearing capacity. That's what I mean. But you have to understand mathematical modeling, how one will develop the mathematical model for a physical system. For that, some understanding is needed. I'll quickly show the flow chart. This is what we're going to do it. Invariably, you're going to get the differential equation, something like this. You can solve all these. The moment you bring in uncertainty in your dependent and independent variables, these equations will going to become fuzzy partial differential equations or fuzzy ordinary differential equations. You please understand, fuzzy calculus is there, fuzzy differential equations are there. Anyway, that is a little high. That maybe people are studying in second level fuzzy course. First level, whatever I have possible, I have already explained. With this, you can think of using finite element. I hope you know what is finite element. Okay, these are some books. This is a big picture about finite element. Okay, we're going to start with mathematically. This is a big picture. We're going to act on differential equation using integration by part for 1D. Then you're going to get a weak form. Then you're going to make these approximations. Then you're going to reduce the differential equation into equivalent set of algebraic equations. If it is a linear differential equation, you're going to get linear algebraic equation. If it is a non-linear, even though because of material non-linearity, you're going to have the non-linear algebraic equations. Basically, computers are very powerful in solving algebraic equation. That is the reason we're going to do this modification in finite element. Similarly, we are going to do the same thing in finite difference using some finite difference form. But basically, both methods are different, FDM and FEM. Okay, you can just think of with this. I'll stop. Shallow foundation example I already given. You can see some books. Okay, you can have it. Okay, and similarly, you can think of. You can use this a finite element model. Anyway, it's a symmetric. You can use 1/2. You can model like this. Now, whatever variables you are giving, E, nu, gamma, those you can treat as a fuzzy set. Then you have to get this functional combination. Okay, these many set of combinations are there. These I have to give as an input to my finite element model. Then you will going to get your bearing capacity or stresses or settlement as a fuzzy set. Then you have to get the resulting. Then you have to do the defuzzification. Then you will going to get the output. That is how you can use fuzzy set. I'm telling only fuzzy set. There is no question of logic here. That means you have variables. You are treating them as a fuzzy variable, straight right. Then you are quantifying using fuzzy set, followed by membership and fuzzy number. Then you can go ahead and then you can draw all these plots. But only thing, they are not like deterministic. Here you will going to have the fuzzy uncertainty associated with these plots. Similarly, you can bring in even solid structure interaction. Basically, the explanation about solid structure interaction. You please think of that's what I have planned in it. Okay. Basically, it is very powerful in case of systems. Okay, you can think of control of vibration of structures during earthquake loading. Okay, that is a system. Please understand. It is a structural activity as well as geotechnical activities. We have to have a thorough understanding about the isolators. Usually, these isolators are provided at the intersection between the soil and the foundation, or foundation and the your column. At that level, okay, here you are going to isolate the earthquake energy. Maybe 80% of the earthquake energy will be dissipated at that level, and then maybe 10 to 20% will be passed to your building. Then building will not going to have severe vibrations. Then the damages will be less. That is how you can build a fuzzy logic controllers. Maximum number of buildings, especially in Japan, they are built using fuzzy logic isolators. Please understand that is what is fuzzy logic applications in geomechanics, especially even in case of this landslide hazard simulation, especially in order to model landslides, especially rain-induced instability and all. People have done a lot. I have given few slides. Please go through that. With this, I will close, but I want to show you one last slide. Okay. Okay, dear audience, with this slide, I will stop here. Especially this slide I have prepared because of this present day pandemic. Life is larger than engineering, and there is much more to education than engineering. Be careful. In the name of education, please should not put your life at risk. Be careful. Okay, fuzzy logic is there. Maybe after a few years, some more logic may come. It may literally solve so many problems. But these are the tools as of now in order to handle the complex problems. With this, I will close my talk. Thank you, one and all. Mr. Girish, I have done my job.
Yes, sir. Thank you, sir. Thank you so much, sir. Very big informative session, sir. Actually, you have explained everything from the application basic.
Yes, because this subject is so vast, you know, it is very difficult. Yes. Yeah, but whatever I have planned, I have said.
Yes, sir. So I request the participants to quickly post your questions in the chat box. I request the participants to quickly post your questions in the chat box so that the speaker can address your questions.
Otherwise, you can read out, Dr. Girish.
Yes, sir. Yes, sir. Once I get the questions in the chat box, I'll definitely read, sir.
Okay.
Yeah. I request the participants to post your questions in the chat box. I will read. Or else you can unmute and talk also. No issues.
No, even though they have simple questions,
yeah,
you please tell them to ask. You don't have to worry about. No questions are simple. Okay.
Yes, sir.
Girish?
Sir, hello, sir. We are looking after that,
No,
sir.
you can do one thing. Any guy is doing PhD in this particular area, in case he's facing any difficulties, or someone wants to pursue is a MTech work or BTech work or PhD work, or some faculty wants to jump to this particular area, I can tell the avenues. There are n number of avenues nowadays. Anyway, you have a lot of YouTube videos are there. When we were student, no one was there to teach this subject. We learned
Yes.
on our own. Later, we
Yeah.
have clarified our own doubts by watching or listening to some people in conferences and all. And then one more advice: self-improvement
Sir.
is the beginning for all.
Yes, sir.
Then don't expect okay, simply by listening to some guys are going to understand subject. No doubt you
Yes.
may learn something, but finally you have to improve on your own. That is the only beginning for all improvement.
Yes, sir.
I think Girish, nobody is interested to ask the question.
Sir, one scholar.
Okay. Even though it is a simple question, please tell them not to worry. They should not
Okay,
feel
sir.
bad. First of all, one should know. Otherwise, what I can make out, people must have understood everything, or else they must not have understood anything. Okay.
Sir, actually,
True extremities are possible in classical logic, no? True or false?
Yes.
It may be true or false, whatever statement. Maybe partially they must have understood. Maybe 20%, 30%, partial percent. That is what is the beauty of fuzzy logic.
Sir, someone is asking the difference between fuzzy logic and GRNN.
What is that? GR?
NN.
GRNN means what? Recurrent neural network?
Yeah, maybe. Sir, Palit,
No, both are
Narayanan,
no.
sir.
Both are coming under the soft computing. So basically, they are used to learn and do something. The moment you bring in, that means the best characteristics of your fuzzy logic and the best of ENN can be brought in, like AnyFish. Okay, there is a model called AnyFish, fuzzy inference systems, adaptive neuro fuzzy inference system. There is a very powerful applicability that is given in a fuzzy logic toolbox. Please go through that, you will understand. Difference will be there definitely. What is the difference between you and me means definitely to be there. Even though we are there in the same division, geotechnical division, even though we have done PhD from the same institute, there will be some difference. The moment best of me and best of yours combined together, what will happen? Definitely you're going to get the ultimate. Like that. Differences are there because it may be okay for some problems, it may be okay for some, but you can bring in the best beneficial effects of both the approaches, you can definitely do better in a particular application. In that sense, they have difference. Otherwise, basically they are same. But basically, these are more general. Neural network, you cannot make it that general. At the most, you can use neural network to quantify the membership function. Let's assume you want to assign the membership function, the membership of this number 5 in a particular fuzzy set. You have some ambiguity. If you have certain knowledge with input output data, you can train your neural network, you can get 0.2, 0.3. At least you can quantify more using your ANN. Other one is the recurrent neural network. I hope they may be talking about that one only, I think.
Okay, sir.
Hello, sir.
Yeah,
Hello.
please tell me.
Hello.
Yeah.
This is Nazir calling from Kakinada, sir. Regarding you have given a very excellent presentation, sir. But as a layman, I'm having knowledge on FEM and MATLAB related things, sir. So, as far as a civil engineering perspective, what is the main age of this fuzzy logic evaluation, sir?
Please just think of, let's assume you have a high-rise building, okay?
Okay.
You imagine a situation, this high-rise building is in Guwahati. You know
Okay,
what is
sir.
Guwahati? Guwahati is a highly seismic region, right?
Seismic region, sir. Okay.
Okay, let's assume all assembly, all your Ministry of Assam is housed in that building, all the departments.
Yeah.
Government means you have so many departments, so many ministers should be there. All their offices, employees and all, they have been housed there. Okay, if you are not designed after construction, you have come to know actual earthquake potential of this particular area is too much. You have considered very less. But already building is there, you have to use that building.
Yes, sir.
After doing certain study, after having a lot of knowledge about the seismotectonics, you came to know that the seismicity of this region is very high. Then at the most, what you have to do? Already you have designed. Then what you have to do? You have to think of controls. Control
Yeah.
means here is the seismic isolators. Control means don't think it's electrical engineering what they are doing. We are also controlling our body, right? If I have a fever, how are you controlling your fever? Using
Yes, sir.
tablet.
Yes.
Like that, control means you please think in that sense. Now you have
So
to have an
there is
isolator.
a remedy for the
Yes. I'm
existence.
telling.
Yeah.
Yes. I'm telling how are you going to bring in. Now what you have to do, you have to somehow jack up your building.
Yeah.
That is left to you how you are going to jack up. You can bring all big cranes and all. Jack up all the columns. Depending on the size of your isolators, you can put your isolator below column and then above putting or whatever pile cap and all. Now you design your isolator. If at all earthquake of magnitude, let's assume you are designed for 7 magnitude earthquake, that may be Richter scale. Let's assume in future earthquake potential may be 8.5. Now you have to design your isolator. Isolator means it's a controller. Basically,
Yeah.
set up some hardware will be there. Depending on the excitation. Excitation is your earthquake loading. Then
Yes, sir.
if at all earthquake will going to come with this much intensity, I can move in one direction. The moment you are moving one direction means what? You are relieving energy. Earthquake means
Yeah.
energy only. All these
Yes.
are energy. During earthquake, it will going to go in one location.
Yeah.
And then maybe a part of the energy will pass through your structure. But basically, you already designed your building. Then nothing
Yes,
will
sir.
going to happen. After the earthquake event is going to over, now you have to have your automatic feedback system. Now earthquake ceased or stopped. Now you have to tell your isolation mechanism to come back to its original. That's
Yeah.
it. That means there are n number. Since 1970 onwards, most of these Japanese have built all their sophisticated buildings on the isolators. Especially in India, it has not come. Maybe in structural engineering, people may be teaching this subject. But
Yes.
in reality, we have to bring in, at least for important structures, where
Yes,
you
sir.
are housing the important people in India. There is no, the important is a qualitative.
Yes,
Okay.
sir.
Whether politicians are important or bureaucrats are important, we engineers are important or doctors are important. Nowadays, because of pandemic, everybody is important. We
Yes,
are
sir.
not simply, we are allowing simply people to die. That should not happen.
Yes, sir.
This is called fuzzy logic. Now what you are doing? No, slight earthquake intensity will be there. Slight means how slight is slight for you. No, understood. The
Yeah.
moment I say slight, you know how to quantify. Okay, I have to construct fuzzy set like this. Slight intensity means correspondingly you can express in terms of PGA. Around 0.1 G, around 0.2 G, around 0.3 G. Once you know this PGA, you can use this in proportioning your all dimensions. Or else you can use your response spectrum. Okay, you know what is response spectrum? It is basically a plot, your essay versus a time period, depending on different type of soil or different region. And then otherwise you can get your acceleration versus time. You have
Yes,
to
sir.
perform hazard analysis. Now your acceleration versus time is not just deterministic. No doubt earthquake itself is a probabilistic. You don't know when earthquake is going to occur. On top of it, you're going to have fuzzy. Fuzzy, when it will come, you don't know much about seismotectonics of your area. You have a rough idea. Then you have to ask some experts. No. You have missed out this. You can quantify. Depending on his credentials, you can assign certain weightage to that guy. Not all are experts. Okay, if you put all experts together, now you construct the fuzzy set. Then you have to quantify. Then you bring in your fuzzy logic. Okay, fuzzy logic means computing with words. Words means here fuzzy variables. To quantify, you have to go to fuzzy sets. Then from fuzzy set, you can operate with numbers. Both
Okay, sir.
forward and backward approach one should follow in this. This is how you can bring in all other, especially in environmental engineering, water treatment, wastewater treatment, pollution control, especially air
Yeah.
pollution. How are you going to control? How will you come
Yeah.
to know? No, you please think. N number of applications are there,
Yeah.
but some
Sir,
applications are
could you suggest me a good book for this one for learning this fuzzy logic operations? Any?
Yes, please. Start with fuzzy logic with engineering applications by Ross. I have given maybe my second or third slide is on that one only.
Yeah.
It is available online. Please just Google fuzzy logic with engineering application. That Ross himself is earthquake engineer. He is a civil engineer. You can just see that that book is the best. You can say it is a class A1 book. Like that, many books are there. You can see more than 3,000 books are there. English editions only. I'm telling English. Then many people have translated, especially in Japan and then China and then European some language. Only thing you don't have Indian translation. That is the biggest problem because we love English, no?
Okay.
Most of the English books only we have.
Yes, sir.
There are many
Thank
books.
you,
I
sir.
already given the list of books, please. Thank you, please.
Thank you for the clarification, sir.
Yes, please.
All right. Sir, how to prepare logistic membership function?
Oh, please repeat once again.
How to prepare logistic membership function?
Logistic is very simple, no? Please Google. Logistic, but you have to see, logistic membership function is not applicable. Basically, in order to make a decision, it is needed, especially in neural network they are using. Now, if it is really applicable for your class of problems, then you can construct. The theory is available online. In all these books they have given. Basically, in civil engineering, we are not using that. In neural network, you are using in order to make a decision. That's it. All functions, whatever you are able to think of conceptually, you can build. Only thing you have to think of their applications. Practical applications are very, very important.
How can we
in the
use,
MATLAB
how can
toolbox,
we
it
use
is given. How can you use in the sense you can, let's assume y is equal to
no
4x1.
sir, how can we use, I'll repeat the question. This is another question, sir.
Okay.
How can we use the fuzzy logics for water distribution systems to supply water to households?
Yeah, it is perfectly all right. There, n number of problems have been solved. Please Google, you'll get so many papers. That is a classic example. Your let's assume to some 100 households are there in that small network. All of a sudden, because of some festival in that city, many people have come to their home as a guest. Then what these people are going to do? Policy makers will come to know, yeah, many people have come. Accordingly, they are going to operate their controller. Controller means basically valves there. You understand? If you fit these controllers, automatic controllers, feedback system, depending on the demand, then you can operate valves. Then this you have to develop some fuzzy, what you can say, system. Fuzzy system and relation equations are there. Yeah, it is possible. The classic example, you will get more than 1,000 papers in that, especially in water treatment, wastewater treatment, distribution, even reservoir operation, especially reservoir operation. There are n number of applications, please. I have given already one or two, no?
Yes, sir. Okay, sir.
Next.
Good afternoon, sir.
Yes, please.
This is Mr. Santosh from Oman.
Okay.
I would like to just pass on to my students this understanding of fuzzy logic and use of fuzzy logic in the laboratory work.
Okay.
See, the concrete is a very heterogeneous material.
Yes,
Right.
please.
When we find the strength of concrete, just a simple experiment I'm talking about. We take normally average of 3 cubes and we set the strength of that concrete.
Okay.
As it is a heterogeneous material, it has many other many ingredients, and each ingredient is having all different properties. And based on all these properties, the strength varies of each ingredient. So
Yes.
how we can come to a close to a single value of strength for a different batch of the concrete?
See, you have to construct the fuzzy set. That is the one way. And then again, credentials are very, very important. Let's assume different batch you are telling. The credentials of that batch mixers. That is very, very important. Let's assume you are having 4 batches. The one is producing M30, another is M40, another M60. You know the composition, especially. In order to produce M30, M40, you may be supplying the same, all the materials to them. At least somewhere you have to have some control. Let's assume one batch mix is going to use some other material, some other material, some other material. You cannot compare. At least something should be common. Let's assume you are going to supply same cement, same sand, same aggregate, everything, or even same whatever your modifiers. Okay. Given that, and then it is basically entitled to the human operations in that case. Human operations, and they are not efficient. That means instead of modeling even apart from your heterogeneous material, you have to model the human intelligence. That means you can, especially Monday to Friday, 12 o'clock. Friday afternoon, let's assume Saturday and Sunday is a holiday. Because this is very, very important. Saturday and Sunday holiday means whatever batch is coming from Friday afternoon onwards, definitely going to have some problem. Because people may not be interested. They may not mix properly. They may not use that many number of revolutions. And they are producing that mix. That is the reason you are going to have heterogeneous strength values. But you have to test the minimum number of samples. 1, 2, 3, 4, 5 is not enough. There are some minimum number of samples. How high is high? The sample number for your particular application. Then only you are going to get a certain number. That means you have to establish the standard deviation. That's very, very important. On top of it, you have to model the human intelligence. That means especially workers who involved in that mixing plant. They are there, please. In this particular book, what I have mentioned, Fuzzy Logic by Ross, this batching plant, an example is given there. At the end of the book, he has categorized civil engineering applications. Again, in civil, how many are structural engineering, how many are water resources, how many are geotech, then chemical engineering, electrical engineering, computer science. All these different fields of specialization he has categorized. These are all given there, please. It is very simple. You have to spend little time on that and then you will understand.
Thank you, sir. Let's hope that we can.
Yeah,
manage.
definitely. Yeah, see, hope is a method. That's it.
Yeah.
In India, what are you doing? Hope is a method. One pandemic will go.
Nice, sir. Thank you, sir. Thank you so much. That's all
Yes,
for
yes, yes.
today's session, sir.
Yes,
Sir.
please. Thank you. See
We will,
you then.
we
Bye
will
bye.
close the session, sir.
Yes,
Yes, sir.
please. Yes,
Thanks
please.
for
Bye bye.
the acceptance, sir. Yes, sir. Thank you. Bye,
Oh,
sir.
fine. Thank you. Thank you. Bye bye.
Yeah, thank you. Bye, sir. I request the participants to give your feedback through the feedback link, and we are closing the session. Yeah, we'll meet in afternoon session by 4:30. Today afternoon we have a session from 4:30, not 4 o'clock. So kindly note this. So once again, I thank Professor Gowda sir for accepting our invitation from Department of Civil Engineering for this AICTE sponsored workshop. Thank you, sir. Thank you once again for this collaboration.
Thank you, Dr. Girish. See you then. Bye.
I'm always happy to be as a student, sir, because you know that moment you are my external and you are my guide for my PhD.
Yeah, 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 yeah. Fine.
Thank you, sir.
Thank you. Thank you. Bye bye.
Bye, sir. So, dear participants, please kindly note today afternoon we have session at 4:30. So, we'll sharply join at 4:30. Thank you once again for your kind cooperation. Even though the time limit is exceeded, I'll share the PPT to our mails. Sir has provided my PPT as well as journals also, and few important papers as well. I'll definitely share that all related to the fuzzy sets, fuzzy logic, and fuzzy things. Thank you. Yes. Today's session will be at 4:30. So kindly note that. Anyhow, we will post in the Telegram also. Thank you once again. We are closing this. Feedback link. Okay, I'll post it once again here. You go through it. Thank you each and every faculty and each and every professor for being having a lot of patience. Thank you. Thank you. I'm closing the session now. We'll meet at 4:30. Thank you.